Good morning, everyone, and welcome to the OCP Telco Workshop and also to AT&T's headquarters here in Dallas. I'm Sumithra Bhojan with AT&T and also one of the project lead for the Telco Working Group. Very pleased to see all of you this morning. And we also have folks joining online. This is a live webcast as well. Like any OCP event, this will be recorded and will be available later through OCP. Want to just highlight a couple, housekeeping items. For the restrooms, the men's are on the left, women's on the right. Please do turn off your ringer for your cell phones. And the Wi-Fi here is AT&T Wi-Fi. And also, if you need to leave the building for any reason, it's going to be a security issue. They will need to escort you back. So I would recommend not to do that unless you really have to. And then please do let one of us know that you're leaving the building. So we'll get you back on, okay? And all of you have microphones. So if you need to talk, ask any questions, I would recommend just raise your hands and tap the green. It turns green. And then once you're done speaking, tap it back to red, okay? And I know, it was a lot of construction and I guess, parking issues. So I do apologize for the inconvenience. But, we'll try to do our best. I think we were also warned that we might have some noise issue with construction, hoping, nothing happens. But, just want you all to be aware of that. I want to take a minute and thank the support team here, Michael, Owen, Patricia, for the support and to host this event. Thank you. Okay. And also, we do have a good lineup of speakers and contributions. So it's right here. Okay. So let's look at the agenda. The morning session is pretty packed with 5 speakers. We'll start off with Archna Haylock's OCP introduction, followed by Craig White providing an update on what's happening with the Telco project group. Then we'll go with the contributions. Jeff Catlin will provide the open aggregation router and also the Cellsite router. And myself, I'll be presenting a couple specs of AT&T's access devices. Then we'll end the morning session with Mike Moore's Edge server and chassis presentation. Then we'll break for an hour for lunch. Thanks to Archna for sponsoring lunch for us. And we'll also end one of our AT&T director, Mitch Patton, will give a talk. And then we will start our afternoon session at 1 p.m. With SDN-enabled broadband access by Saurav. That's going to be a remote presentation. Unfortunately, he couldn't be here. We'll do that, followed by more of edge compute infrastructure by Jeff Sharpe. Then we'll finally end with Kylie's The Gateway to New Paradigm. UFISpace is a new member of OCP, so welcome. We kind of have like an hour of group discussion towards the end. I think it's from past experience. We've had folks stay back and discuss some new ideas and thoughts, and that usually, becomes some new contribution for the next meeting. So it's an open discussion. So feel free to bring new ideas or anything that you want to share. Also, time to catch up on maybe Q&A if you don't get to ask questions during the contribution. So that'll be an open discussion. So with that, let me hand over to Archna Haylock. She's the director of OCP Community.
Thank you. Thanks. So I've had a chance to meet some of you, and I'd like to meet the rest of you, so hopefully we can connect over lunch. We put a video together on OCP, so how many people here, this is the first time they're attending an OCP workshop? All right, okay, good to hear. Okay, so it's probably about 70-30, which is great. If you could cue the video, if you could bear with me for about 2 minutes, that'd be great.
The Open Compute Project. But what exactly is it, and how do you get involved? Let's rewind. In 2009, a few engineers, hey guys, at a company, hey Facebook, realized in order to accommodate their huge influx of data, they'd have to rethink their infrastructure. So they set out to build the world's most efficient data center. And they did. But it got them thinking, if open source collaboration could create a software revolution, couldn't it do the same for hardware? So Facebook shared their knowledge with the world. And with the help of Intel, Microsoft, Rackspace, Goldman Sachs, and Andy Bechtolsheim, the Open Compute Project was born. Today, OCP is a thriving global community with hundreds of member companies and thousands of engineers collaborating to break open the black box of proprietary IT infrastructure to achieve greater choice, customization, and cost savings. Our project communities are led by volunteer leaders and overseen by our incubation committee to guide initiatives in data center facility, hardware management, high-performance computing, networking, open system firmware, rack and power, security, server, storage, and telco. The result? Member organizations and solution providers collaborating to create embedded software, firmware, hardware, and facility guidelines based on OCP's tenets of efficiency, scale, openness, and impact, improving the efficiency of data flowing from the edge to the cloud worldwide. So, can open source collaboration create a hardware revolution? It already is. Join us at opencompute.org.
So that's a little bit about OCP for those that are attending an OCP workshop for the very first time. So I'm the community director for OCP, and what that means is I'm responsible for the members and their happiness within OCP, how they collaborate, how they work together, and how they connect with each other. So if you have any questions about getting involved with OCP, I'm usually the person that you talk to. So this is our staff. We have several different people that you've probably met at OCP summits or workshops, but primarily the 5 people that you need to get to know are myself, Steve Helvey, who is our VP of Development, Bill Carter, who's our CTO, Dirk Van Slyke, who's our marketing person, and the newest addition to our company, or to our foundation, Rajiv Sharma, who is responsible for software and technology. So a little bit about OCP. You saw the video, but we've grown quite a bit since 2009 when it was first brought forward with Facebook. We're about 200 corporate members. We consist of adopters, we consist of suppliers, as well as solution providers. And our suppliers are both hardware and software suppliers. We've got about 6,000 participants in our community, from every walk of life, sales, business development, manufacturing, academia. We're now starting to see the government get involved, as well as facilities, colos, as well as those that have their own data centers. And then we have membership companies from all over the world. A little bit about what was disclosed in March at our summit, our global summit. OCP's impact is way bigger than what we expected. We had an independent company come out and do a study of what exactly OCP meant to the community. And basically what they came up with is that we had double-digit growth. Today, our impact in 2018 was $1.2 billion. And when I mean impact is people are looking around at OCP, shopping open products, shopping for open software, shopping for open solutions. And as you can see, that growth is expected to grow so much more over the next 5 years, especially in Asia. So as you go and see OCP and take a look at our memberships, we have 4 different levels. The community level is the bottom level, but it's the participation level. That is our largest community right there. People that are actively joining, actively listening, actively participating. And then the silver, gold, and platinum levels are really people that are making contributions. Contributions in terms of, getting involved, in terms of leadership, in terms of time spent, in terms of sponsorship of events like AT&T is doing here. So a couple of requirements that are needed in order to get up into the upper tiers. There are annual contributions, and what I mean by contributions are, there are things like white papers, specifications, case studies, design files, even products. If you're building products based on open specs, we want to hear about it. And these are some new requirements that came in March of this year. There are opt-outs available because we realize not everyone can contribute, but there's also opportunities for you to contribute in all sorts of different ways. And I'll talk about that in a few minutes. You heard, we're here for the telco project, and you heard from the video that there's lots of other projects, and we have a lot of subgroups. In fact, one will be launched today, the Open Edge one, and that's under our telco group. But as you can see, each project is working on different work streams. Our networking project is working on open networking Linux, open networking install environments, switch abstraction interface, Sonic, campus branch wireless. Our rack and power group just launched 2 new sub-projects, one on cooling solutions and one on power shelf interoperability. Our CTO couldn't be here today because he's launching yet another subgroup today for our storage project. It's on archival storage. They're looking at tape, they're looking at optical, they're looking at all forms of storage that a data center or a telco may need in their environment. We just launched a modular data center project within our data center facilities group. In our Amsterdam summit, also talked about 2 pilot customers that are now looking at modular data centers. They're building modular data centers. And if you're interested in that, Brevin back there is leading our data center facilities group. We're also looking at a new project that might be of interest to you guys, which is Open RMC. We're looking at the rack management controller now, and trying to see if we can get folks like AT&T, Nokia, Inspur, Intel working together to figure out what is a common platform for rack management. And that's just being launched. In fact, we're still trying to figure out how we're going to work together. But these are all brand new communities, brand new requirements that are coming up from our communities, and a need to collaborate, a need to bring forward challenges that they're facing, and how we can work together to solve them. So how can you get involved? Well, you can join OCP. If you're not already a part of a mailing list, you can get on a mailing list. You can help drive project focus. So if there is something up there that isn't being addressed today, definitely bring it forward. Bring it to me, bring it to Craig, bring it to Sumithra, bring it to Brevin. Bring it to the team here, and we will make sure that we can find a way to get the community involved and get the projects involved. We're going to be having our IC leads going up for election in June. It's a 2-year term. So if you're interested in running for our incubation committee, part of our steering team, that would be great. We would love to hear from you. Contribute. Like I said, you can contribute traditional specs and designs, but you can also do a lot more with your subject matter expertise. We would love to see case studies. We would love to see software that you're running on open hardware and testing those configurations. We would love to see reference architectures if you're using those in your environment. We'd love to hear from you. So there's a lot of different ways that you can participate in our project communities. You're already attending a workshop, but we have our global summit coming up in March of 2019 in San Jose, California. That is by far our largest event. It's a global event. It's about 4,000 people, 2 days of packed agendas, listening from not only our leaders out there, but also from all the other project communities. New projects announcements, new product announcements, new software announcements. It's a really, really great way to get involved and really find out about OCP. So one thing that comes up a lot is, oh, contributions, contributions. What does it mean to contribute? And I'm giving away my IP to OCP. That's not the case. OCP doesn't do anything with IP. The IP is retained by the contributor. What you're doing when you're submitting a design or a specification or some embedded software, you're really just doing it through a royalty-free patent assert. You still retain your IP, but all you're doing is the people that are using that IP in the community, you're not going to assert your patents for that specification. Doesn't mean you're giving it up completely. It's within your purview. If you are building a product and you're just building it on an open spec, well, the spec is already opened up, and you're not giving your product away to OCP. All you're doing is applying for a validation and a recognition. And that's what we do, is we validate that something about the product is open. And then we go ahead and we certify it on our end. So it's kind of nice when people build specs and then people build products on those specs, that we kind of have an idea of what is being built and what is out there, and we want to make sure that we know about it. So that's part of the product recognition. But the IP still remains with the contributor. It doesn't get assigned to OCP. Let's see. So what can you contribute? We have our traditional contributions with specifications, with design files, with products, but there's a whole lot more that happens behind the scenes too. The design packages that are there, we have a template online. You can go and see what kind of, what's the specification, what does a specification look like in the OCP world. It's a little bit more than a data sheet, and it's really giving the person that's using the product more insight into what the product is. So the specification is a little bit more detailed. The design package that you submit, if you decide to submit it, is very inclusive. It includes schematics. It includes Gerber files. It includes the BOM. It includes any source or binary files if you're doing an embedded software contribution. So it's kind of really neat when you take a look at the spec, and you can go online and download a spec and see exactly what the spec looks like. And although all that information is completely free to anyone that wants to use it. There are no passwords on the OCP website. There are no passwords on our wiki. You can go online and you can get it today. It's kind of neat. Some non-traditional contributions that we introduced in March really had to do with the fact that a lot of our adopters were looking for ways to participate in OCP. So we said, great, if you're using a reference architecture with open products in it, please let us know and publish that reference architecture. If you are having a case study where you compared traditional hardware to open hardware, we want to know about it. And so you're going to start to see a lot more white papers. You're going to see a lot more case studies coming up on the OCP website. Workshops like this also count as contributions. Testimonials that you give us, videos that people have done on OCP product, those all work. So there's so many different ways that the community can really come together and learn from each other. So I'm kind of repeating myself here. Lots of ways to get involved. So I talked a little bit about the product recognition program. So if someone builds a product on OCP hardware, on an OCP spec, and that spec is 100% open, meaning that the source files, the design files, the BOM, everything is open. When we see that product come forward, we recognize it as a OCP accepted product, and we give the supplier a green symbol. And what that means is that if anyone wanted to go and build that product, they technically could, but it's also going to take them a long time to build the product. And we haven't had, at least in our ecosystem so far, with all of the specs and design files that have been contributed so far, nobody has gone out and replicated a product. It just doesn't work that way. I think it's just more for the adopters and the solution integrators to really get to know their suppliers. If, however, you wanted to keep your design files closed, you can absolutely do that. It still is recognized because something about the product is open, the spec is open, and the supplier as well as the adopter can go see that spec, and that's what it means when we give it a gray symbol, and that's OCP inspired. It's been inspired on an open product. So what we do is, as a foundation, we validate that something about the product is open. For adopters, they look for this symbol to say, okay, I can either download the spec or I can download everything about the product. And for suppliers, this program is completely free. So you can get the logo, you can go advertise it, you can put it on your RFPs, you can put it on your RFIs, you can do all of that because, again, it's been validated. We introduced a new program in Amsterdam of October this year called a facility recognition program, because a lot of colos came to us and said, hey, we have now equipped our facility to be ready to receive OCP product, and we want to be recognized for that. So the team got together and put a huge set of colo guidelines, and basically what they do is it's a self-assessment. They fill out the self-assessment, and that assessment gets published, and the facility gets an OCP-ready certification mark. And so what you'll start seeing now is on our marketplace, you'll not only see products, you'll not only see white papers and documents, information documents, but you'll start to see OCP-ready facilities. So as an adopter, if you're looking at a facility and you want to use open products, you're going to start to look for that OCP-ready symbol. And these colos are now going to be part of our solution provider ecosystem, and they're going to be now colo solution providers. So Marketplace will have not only our traditional solution providers, but it'll also have our colo solution providers. So as you start looking at your own ecosystem, start thinking about OCP gear. You can go online. You can either become, if you're a supplier, you can become an OCP solution provider or an OCP colo solution provider. As an adopter, you might start thinking about using OCP in your own ecosystem. And if you go to the marketplace, you'll get a whole list of solutions that you can use, along with people that you can buy it from. And if you're looking at facilities, you can also go to the marketplace now and start looking at OCP-ready facilities. So in conclusion, my call to action is for everybody here, the 70% that raised their hand and said this is their first workshop, please go to our website. Each project has a charter. Take a look at it, read it, and see if it falls within your interests and within your purview. Each project has a volunteer leader. In this case, there's 3 people present here from the telco project. There's Craig, there's Sumithra, and there's Jeff. Introduce yourself, get to know them, because you'll hear from them a lot on the project calls. Each project has a wiki page, and the wiki page will have work in progress. That means specs in progress or initiatives that are going on in progress. It will have all of the recordings of every single project call that is held, along with the presentation that was given, because it's a YouTube recording, and you'll be able to see exactly what has been going on in that project. So go online, listen to it, and if you miss a project call, because they occur monthly, and in some cases they occur twice a month, sometimes they occur once a week, you can always go back and get it again. And then, again, all the calls are recorded, as are workshops here. They're all available free of charge. We have a lot more workshops coming up, so go to our events page and take a look at that. If you missed the Amsterdam Summit, you can still go and see every single presentation online. So we kind of pride ourselves of the fact that everything that we do is completely open and completely transparent. And then as you look at your own ecosystem, think about OCP. Not just to contribute, but also to adopt. So with that, does anyone have any questions? Cool. I like it. All right, thank you very much. All right, are you up? I think we're 10 minutes ahead.
Hello, everyone. So myself, along with the first speaker, Sumithra, are the co-leads of the Telco Working Group. And what I'd like to do is to provide a status update for those who missed the regional summit where we presented this information. And also for the new folk, we're really excited to have you here. We're happy to have new folk coming in. Is the lifeblood of any open project. And we'd like to have your input. There's a couple of housekeeping things I'd like to get out of the way, because one, I'd like this to be somewhat an interactive thing. In front of you on the desk, there's a microphone, and it should have a red LED. And if you touch the little white part, it'll turn it to green. And when it's green, you're able to be heard. And so one of the things that, as was mentioned earlier, all of our proceedings are recorded so other people can hear. And so we'd like to get your input incorporated into that as well. So when you have a question or a comment, there's probably someone else that has that as well, either in the room, on the recording, or in the live presentation that's being broadcast out from the room today. So if you would push the button, and we'll help you along with that too. If I can't hear you, I'll say, hey, would you mind pushing the button? It's kind of one of the things that I'm known for that. And Here we don't have to run the mic, so running around with the mic and asking people to speak into the mic. So the way the projects work, and as you notice, there were several projects of different types and varieties. This one has a telco focus, which has products that are and submissions that are related to telco in some way, and we like to call it fellow travelers. So these are telco providers, suppliers, solution providers that are traveling down a path together, trying to move forward in a brave new world for the telco market, more of a cloud world than a in a cloud world. Let's leave it at that. So basically, we have a mailing list, which is the main way that things get done. We have 400 subscribers to the mail list. Over the course of the telco project, we've had 7 submissions that are approved, specifications. So these are things that have been introduced in a workshop and have been discussed among the members of the project, either through the mail list, through in-person conversation, and have then gone to the incubation committee and have been approved and are now part of the open compute products, okay? And the work products, the work topics in the past have included several XPON, which I think will continue. This is an evolving and continue to grow. And we'll have some talks on XPON again today. We've had topics on high voltage DC power. Not all of these are ones that have made it all the way to IC approval, by the way. I'm just kind of giving you a list of some topics. There's the Open Fiber Distribution Hub, the GFAST, the Cellsite router, the micro CPE, the carrier Open Rack 19, and several other hardware items. And so all of these things can be found on our wiki. And one of the nice things, which we'll come to later, is a lot of people like to take pictures of slides. And I'd like to make it clear there's one slide in particular that you want to take a picture of, and that's the one that has the URL for the wiki. Because from the wiki's URL, you'll be able to download and view each of the presentations that are presented today, but also every presentation that's been presented in the Telco Working Group since the inception, along with most of the calls, the audio of the calls, and the presentation material synced with those. Recently, we've had 2 approved specifications. We've had the Edgecore ASX OLT16, which is an implementation of an AT&T contribution specification. And Deutsche Telekom released a specification on the Open GPON OLT. And so, at the bottom there is the list of the URL for the Telco Wiki. And once you've been involved in the open compute for a while, then all of these things kind of make sense where it's wiki / the name of the project. So for any spec that you may like to find more information on, whether it's racks, servers, storage products, networking products, you can go to the wiki and actually download those specifications and read them to get a better understanding of what the technical details are. As long as they're an accepted spec, it's very detailed. as Archna said, all the way down to Gerbers, step files, those kinds of details. So, I have a question. I'd like to segment a little bit better. So, Archna asked how many people were new. Can I ask a question on how many people feel that they're an adopter or a user of OCP, and how many would feel that they're a supplier or a provider of OCP products? So first, are you an adopter of OCP gear? And then, so that leaves the rest as being, okay, both? Okay. All right, so this is kind of a typical thing that we've seen. There's usually adopters have it. It's kind of like the dating sites. The adopters are there's usually a big mismatch between the adopters and suppliers, because it takes a lot of different parts and components to make up a solution. So it's not just that. I know of the people that participate in the telco group. They're not a solution provider typically, but they aggregate a lot of components. So we have several different layers of suppliers that participate. Okay, so if you're not involved, join us. It's driven by member contributions. And again, I'm going to talk about contributions for a minute. I know we just had Archna just talked about contributions, but this is really the lifeblood of any project. And so the more contributions, the more ideas that we have coming in, the more interesting topics that we can cover, and the more solutions that you can get out of the project. So the first type we talked about were the specifications, the design files, and the products. And those, after collaborative engineering, become the products that we talk about as the OCP product. But one of the more important things, especially for telcos, we've noticed, are the reference architectures, the case studies, just the user experiences. So a lot of people are like, hey, I would like to use Open Compute because it has some really attractive features. If you have the opportunity to go to a summit, one of the things you'll find out is that using Open Compute products tend to save money not only from a CapEx standpoint, but more importantly from the OpEx standpoint of the power efficiency. You end up reducing these long-term costs, the recurring costs on equipment. And so when a lot of people then want to move to OCP gear, and they go, hey, how can I use this? How's it been used? Is there another fellow traveler who's using it in a similar way to the way I might like to deploy it? And so without having reference architectures, white papers, some tested configurations, it's hard to understand how all the pieces fit together and make a cohesive whole, right? So if you have any ideas for innovation, if you'd like to learn more about deploying OCP gear, this is the place for you. For carriers, this is the place for you to disaggregate and to innovate. So this is a kind of a catchphrase for the service providers. So a lot of the services are being disaggregated and allow you to innovate. So if you would like to, wondering where you can find fellow travelers or other people who are interested in that same goal, this is a place for you to explore your ideas, and we would love to explore them with you. So then I'm reading from the slides anyway, but the last couple of sentences are actually from the charter, and I'll leave it, give you something else to read instead of me. You've probably already read it, 10 minutes ago when I switched the slide over. But what I'd like to say is we have a charter for what the group works on, what's in scope, what's out of scope for the work. And these couple of sentences kind of, sum up in a nutshell what the Telco Working Group is about. And again, if you'd like to see the charter, you have input for the charter. It's available on the wiki. Actually, it's on the front page of the wiki. You click on it, and you can then read the charter yourself. So then, as I said, the way the project is organized from a work standpoint is there's 2 co-leads. And our job is not to do the work necessarily, but to shepherd the work that you guys do, to provide an interface to the foundation, to help you navigate your way through making contributions. And we're happy to help in that. We host the calls, organize the details of the calls, host the work groups. One thing too, there will be technical details today, so this is not necessarily a marketing sales kind of event. The summit tends to have a little bit more fluffy, cartoonish diagrams, but here you're liable to see some more detailed engineering work because it's actually an engineering workshop, which is somewhat refreshing to those who are used to going to an event or an open project meeting and seeing a lot of just product talk and people talking about here's what we're doing, as opposed to actually working on some details. And so anything that comes up today, we're open for input. So all of the talks, whether they're wanting them to be interactive during the talk or whether they'd like to, you'd like to ask questions at the end of the talk, you can kind of figure out what's best for that, or the speaker may ask for that at the beginning or whatever. And please, feel free to voice your opinion, because that's the way these things get better, is because, together as a collective, we get more knowledge than any one person alone. So then I'll point out Jeff, he's actually, today I didn't wear my engineering shirt. I didn't have a plaid available, but our incubation committee person is Jeff Catlin, and he'll actually be presenting on a couple of specifications or products that they're using to meet some specifications. So then there's some quick links. If this might be another one, if you like taking pictures of things to remember, these are some good things to remember. Join the mail list, and these are ways to participate as well. So join the mail list, and I will say that I've noticed we have to approve the members to the mail list, and I've noticed that in the weeks leading up to this event that we've had several people join the mail list, and I've seen a couple of different names and companies that maybe it's not you, but someone you mentioned to in the company that you were going to this event, and I have seen a little uptick in the number of joins on the mail list. There's also a link to our project calls. We have call once a month, and we alternate those calls between 1 p.m. Eastern and I think it's 7 p.m. Eastern, which is for the Asia Pac and the North American. We don't really do much for the Europeans. If there's enough interest in that and people bring up the topic, we can certainly accommodate that and have one off so that not everyone's either getting up in the middle of the night or And then there's a link on how to contribute. Okay, so that's kind of it for me. Does anybody have questions, comments, things that aren't clear that I could help you with? Seriously, neither me nor Archna made anybody have a question of the new guys. Everybody understands the wikis, the mail lists. We're all ready to go. All right, well, we look forward to your participation and hope you enjoy the conference or the workshop session today. For the new ones, the old guys, I'm sure you'll get a lot out of it. Oh. I'll leave that for you there, Jeff.
Should be pretty easy. Green and red, even I can understand this. Let's see. Good morning. Thanks for coming. My name is Jeff Catlin from Edgecore Networks. I'm also the incubation committee representative for the Telco group. A couple things before we get started. I just, from Boston area and flew in this morning. Anybody from LA or Dodgers fans here? Just checking. Also scanning the audience for plaid engineering shirts. 1, 2. I didn't know that was the case. So I have a couple presentations today, short presentations, can take questions at the end, on some contributions that the company I work for has recently done. So I'm not only the IC representative, I actually work for a supplier who's very active in open compute. So again, the agenda, a couple presentations, and then some Q&A at the end. So who is Edgecore Networks, if you're not familiar? So Edgecore Networks is a wholly owned subsidiary of a company called Acton Technology Corporation. So Acton Technology Corporation is a network ODM, equipment supplier. It's been around for 35 years and based in Taiwan. Edgecore Networks was created 10 years ago or so to be the avenue for Acton and the brand to get their products to market, because traditionally Acton just deals with OEM customers. Okay, so it's really that simple. So the first product is a open cell site gateway. Okay, so why are we contributing open cell site gateway designs? Well, it's fairly obvious to, I'm sure, everybody in this room, the explosion of cellular data traffic and usage is forcing upgrades to the network, and with 5G on the horizon, okay, it's time to upgrade to cell site gateways. This also makes perfect sense because cell site gateways are cell sites are so numerous. Cell site gateways, there's very many of them in a network, and a great place to start to enjoy some benefits of open networking. So the benefits, high-level benefits of open networking that an open project brings to the table is the removal of single vendor lock-in. So no more is there, one vendor that's holding a customer hostage with a hardware and software combined solution. You can go out and source your hardware from one supplier, or many suppliers, and source your software from one or many suppliers as well. With that, there's a whole line of new operating systems. There's commercial offerings, and there's open source offerings that run on these open platforms, including open cell site gateways. And that allows a lot of choice and a lot of feature differentiation between these commercial packages or software packages, really depending on what the operator needs for features. And lastly, simple things like removal of vendor lock-in on pluggable modules. So for those people that deploy these products, they understand how expensive a pluggable fiber optic module can be when it's locked to the hardware. Okay, it's many, many, many times more than it needs to be. So those are kind of the high-level reasons why open cell site gateways. Some of the high-level requirements for the open cell site gateway, it's outside plant compliant, so it has to run from very cold temperatures to very hot temperatures. 19-inch rack mountable, 300 millimeter depth, so it has to be able to be installed in street cabinets and run under these environments. Has to have redundancy built in for power supplies and fans. Support a broad range of clock synchronization techniques, including 1588 and synchronous Ethernet. And the ability to support long-haul optics. So those optics may have drive distances on the backhaul greater than 40 kilometers, so you have to be able to drive 40 or 80 kilometers on the uplinks. This picture here, I scraped from an AT&T presentation in Texas a while ago, but it's just a high-level drawing, and you may see this again today, of where cell site gateways fit. And obviously, they fit very close to the cell site itself. And they aggregate cell sites, and they aggregate the equipment on the cell sites as well. So this is our product contribution that matches those high-level requirements. This product contribution conforms to the AT&T specification that they contributed to Open Compute. As you can see here, this design has 24 ports of SFP ports with a couple 100 gig uplinks. It's a deep buffer architecture. It's based on a piece of silicon from Broadcom in their DNX family. So it has gigabytes of packet buffering, not megabytes. It's fully NEBS 3 compliant. It meets the timing requirements that we went over before, and it has AC or DC power supply options. On the top of the switch here, what's shown is a couple commercial software partners that we've already lined up that are porting their software to this platform. And below the hardware platform here, you see a list of boxes underneath there. Those are different open source software modules that we provide with all of our open hardware designs, which are available for this cell site gateway as well. So a further look into this, and you guys get all the slides. Standard stuff on the front, removable power supplies, you know, your 100 gig uplinks, 24 SFP ports. Some of those are 10 gig only, so they can run at 1 gig or 10 gig with SFP pluses. 8 of those are capable of SFP 25 gig connectivity, so they can run at 1 gig, 10 gig, or 25 gig. So on those 24 ports, you have a mixture of 10 gig or 25 gig capable ports. Okay, and then there's various timing input and output ports on this design as well, okay, on the front. Of course, we have to put in a block diagram because I have on my engineering shirt today. So you guys can get this, but you know what the kind of takeaway from this is in a 300 millimeter deep design with all those optical components on the front end and all the timing circuitry. It's a very compact design that has to meet those harsh temperature environments from the -40 to +65. So a very, very compact and very efficient design. So we've talked about this a couple times this morning. What is a design contribution? So our design contributions that we do in the networking group and also the telco group are full design packages as well as specifications. So we go for the OCP accepted status, and that means we contribute everything listed here on the slide for review by the incubation committee, and then it gets voted on, and if it's approved, it becomes an accepted design, and all this information is public, including a specification on the hardware, a hardware specification in paper, software programming guides, the actual schematic files, the Gerber files, the native board files in their format. These are Allegro in this situation here. Mechanical step files, any CPLD or FPGA code in source format and binary format, and a test plan. So if someone was to recreate this design, they would have a plan to go out and test it and know that the design is functioning as designed. Okay, so all that is contributed with the design. The schedule of this design here is, the specification was contributed just before the October European Summit. The design files were pushed to the server at that time as well. The incubation committee has reviewed all the information. I can say this morning now that this design has been accepted as of late Friday. So the voting ended Friday on this design. So now this design is an OCP accepted design. As far as the actual product schedules, software units are being distributed to software partners today that were shown on that previous slide. We expect POC and field trials to begin late Q4 of this year, and then volume production of this would be Q1 of next year. So right on the near-term horizon here. Okay? So that's the first contribution of the Cellsite gateway. Another contribution we did at the summit in Amsterdam was the specification of an aggregation router. So again, we go back to this picture here. Cellsite gateways sit closer to the cellular equipment at the towers. The aggregation routers sit one step up, and they may aggregate traffic from these Cellsite gateways. So a very simplistic picture of where the aggregation routers may lie in the network. The reasons for contributing designs around an aggregation router are very similar to the reason for Cellsite gateways, right? You're replacing or installing all these new Cellsite gateways in your network. They have 25 gig, 100 gig connectivity. 5G just makes more of those gateways be deployed in the network, so that puts pressure back up in your network on your aggregation router. So it makes sense to upgrade those in the near future, right? Same list of reasons why you would enjoy open networking for your aggregation routers. Requirements of an aggregation router are very similar to the Cellsite router, rack mountable, redundancy, clock synchronization, those types of things. However, it's not outside plant compliant, although it is NEBS 3 compliant, but not outside plant compliant. So it doesn't have to go to -40 to +65. Deep buffering, large TCAM, ability to support long haul optics, those types of things in an aggregation router. High density 100 gig connections with future 400 gig connections as well. So this is, we contributed the specification for these products, and these are the products that we showed at the summit in Amsterdam. So there's two initial SKUs here. There's an 80-port 100 gig design and a 40-port 100 gig design. Okay, so these are both based on silicon from Broadcom in the DNX family called Jericho 2. These designs support the expandable TCAM and statistical capabilities through another piece of silicon, which we'll talk about in a minute. Support for synchronization techniques, AC/DC power supplies, and these we feel are building blocks for additional products that come out in a family of aggregation routers. These are just the first two. Again, on the top of the picture here are commercial software partners that are actively porting their software to these switches. And on the bottom, again, is the list of open source software components that we offer with these designs as well. So we had block diagrams, and now we get into cartoons. We mentioned cartoons earlier. So now we have some cartoon pictures of what these designs look like. And kind of the takeaway here is the building block aspect of these designs. So on the left side of the slide here, you have the main PCB board. Okay, and this is what makes up a 40-port 100 gig design. It has a single Jericho 2 forwarding ASIC on there. It has a piece of silicon from Broadcom called the OP2, which is expandability for the TCAM and the statistical gathering capabilities. It has gearboxes in front of that Jericho 2 ASIC to convert PAM4 50 gig SerDes into native 25 gig NRZ SerDes for standard 100 gig connectivity out the front end. And then you have your QSFP28 So that yields, on that baseboard, 40 ports of 100 gig. And on that is a modular CPU. So that CPU complex is modular. It's a daughter card. It plugs in. We have Xeon class CPUs. We have Atom class CPUs, various x86 CPU options. On the back end of that main card is a connector, board-to-board connector. So you basically take the same card, that's the main board, and you plug it on top of that. You take the mezzanine card, plug it on top of the main PCB, and that gives you another 40 ports of 100 gigs. So that equates to the 3RU 80-port design, right? So building blocks as you go out. And you can envision if you were to remove the gearboxes in this design, that would net you native 400 gig interfaces instead of 100 gig interfaces. So these are the most complex designs as far as amount of silicon in the designs, and you would remove pieces of silicon to make different variants of these designs, whether it's native 400 gig or a mixture of 100 and 400 gig. So the schedule of these, the specification we contributed at the summit. Design package, as far as design files, we would really like to get some feedback on the initial design specification, which is public now on the wiki. So we're targeting the end of Q4 to have the design files for what we showed here, the first two designs, available for the community to review. Schedule for these two products, the 40 and 80 port that we showed here, we're distributing initial samples to software partners at the end of this month, so this week. POC tests we expect in Q1 of 2019 based on this silicon, and then volume GA of these two products here sometime late Q1, early Q2 of 2019 based on software support from those vendors that were shown on top of those products. Okay, so what's next? As I said, we feel these are a family of aggregation routers that we'll be bringing forward into the telco group here. So, we think there's still plenty of work to do. Again, you can envision that mezzanine card design. You remove some gearboxes off that. Now you have a mixture of, 40 ports of 100 gig with 10 or 11 ports of 400 gig, so a mixture 100, 400 gig solution. You could have total solutions that are all 400 gig designs, and the list goes on and on and on. So we'd like to get some feedback, excuse me, on that specification that's out there from adopters of OCP hardware, and really kind of make a product family here that satisfies a bunch of different use cases for multiple operators. And the follow-up, right? So if you're a consumer, you can purchase these types of products on the OCP marketplace. So it's a great place to go and look at who's contributing, what products are available for purchase, not just from the company I work for, but many other companies. Download the detailed specifications that are on the wiki page. Give them a review. If you get feedback, post it to the mail list. We'd love to see some feedback on these designs. If you're a supplier or a vendor, don't be afraid to get involved and contribute. It doesn't hurt that much. And that's it. If there's any questions, I can answer some questions. If not, yes.
So what are the technical challenges to implementing the 400G interconnects in those designs?
Interconnects on...
Well, you showed, what's next. I was just wondering, what are the technical challenges that you see?
I don't see any technical challenges with the 400 gig. We have other designs that we've contributed to the OCP networking group based on Tomahawk 3, another piece of silicon for Broadcom, a 32 by 400 gig design, which has also been fully OCP accepted. So we and others have 400 gig designs today. So I think the technical challenge on the 400 gig designs is the optics, the plugins. It's not the electrical design and the PCB. I think that's worked itself out, and the thermals. So I think there's many vendors able to do that.
Yes, I know how you come out ambient temperature, 65 degrees C. How to come out this number, 65?
That was part of the, it's either 60 or 65, I don't know which. It was part of the specification that AT&T put forward for outside plant compliant designs to run at those temperatures. The outside temperature, right? The high temperature? Yeah. So that does the Cellsite gateway router that I showed, it follows the design specification that AT&T put into Open Compute as well. So, you know, they have their specification which says these temperatures, this size, this many ports, that kind of stuff, and then our product fits underneath that and matches that specification, as does, I think, maybe another design which we'll hear about today.
So that is outside, but how about the power supply? The power supply ambient would be higher. Because inside is power supply, right? So
Hey, could you turn your mic on for us?
I'm not sure I follow. So the temperatures there were the ambient temperatures the design has to operate in, not the internal temperatures of the components. Anybody with a plaid shirt?
Could you take a minute to outline what it looked like to get the design accepted? Either of these designs, I guess the first one that is finally accepted. What actually happens? What's the detail there?
So the process is to have a design totally accepted, and I don't know if Archer's in the room. She may have to help me out on the process, but you have to be one of those upper 3 tiers of members to get an accepted product. So it's silver, gold, platinum, I think. And then it's working with a group, like the telco group or the networking group or one of the groups, on your idea. It's proposing your idea in a specification that gets reviewed by the community.
Yeah, let me just take you to another level. I'm just
Okay.
looking for the details. Like you had it done, you know, you've met all the kind of the checklist requirements for OCP, but you know, how much were you grilled on the details of the design? You were holding it up against an existing specification. It had to meet all this. You claim it met all this. How much back and forth was there to prove that it actually met the requirements and all of these kind of things?
As far as proof,
Maybe we should start at the beginning. I think the part
in the
that,
beginning,
yes, the part that's missing is that there was an adopter, and in this case, the adopter was AT&T, and they felt that they would like to have a product, and they wrote that a specification. They expressed that desire in an OCP specification. They brought that and presented that to this group, and the group talked about it. Hey, you thought about this, thought about that, you need this, you need that. Suppliers would say things, you know, component people, hey, if you use this, if you use that, la, la, la. That became a specification. Okay? Boom. Now, Jeff's company said, hey, we would like to make a product that meets this specification. And so in his talk, he referred to those as requirements, and he kind of distilled out the important pieces, perhaps, I'm putting words in his mouth, of that specification, and then made a product and decided that that product should be an accepted product, which meant the schematics, the Gerber files, the step files, everything necessary to manufacture that product was then presented as a specification. And again, that was talked about and debated. Oh, and I'm sorry, after it's talked about here, it goes to the incubation committee, right? Which there's a representative from each of the groups. So to ensure, in this case, the telco group was making a networking piece of gear. So at the incubation committee level, there's a representative from the networking group that would, you know, have more expertise perhaps on that. The server, you know, has a micro server built into it. That becomes part maybe of the server group. So the incubation committee vets that design, probably has some things to say about it, sends it back, comes back, okay, votes on it, yep, we'll accept this. And so that's the way that the products in OCP are typically as a typical flow, there's some details that Archna would be happy to talk about of what level of member you need to be to participate, that kind of thing. But in general, that's kind of the flow of a product's life cycle, if you will, in the OCP. And it's quite possible too, though, that Jeff could have produced a specification document and then a product that met that specification, as provided everyone was, the IC was happy with that specification and was happy with the product that they had produced and that it was going to meet the tenets of the open compute organization.
Yeah, that's exactly correct. So historically, there's been two ways. One is the consumer-led project where a consumer such as AT&T or other carrier will specify exactly what they want, and the product will fall out from that. There's a flip side of that, that my company and other companies, they have products which they feel are worthy to be put into the marketplace, and they come up with their own specification and their own design and then contribute that independent of a consumer for the product. What I'm personally trying to do on the last thing I presented here is kind of do something a little different, where we came out early with a specification of those aggregation routers. And I'm wondering if there's a way where we can really get feedback from multiple carriers on that specification so we can make a product in the group that fits multiple use cases and multiple suppliers rather than point products all the time. So that's kind of why on the third product it's a little early in the development cycle, although there's samples and there's a schedule. There's still a lot of innovation to do. There's still changes we can make as those go through, cleanup respins and that kind of stuff. So I'm hoping that on the aggregation routers we can kind of maybe combine those two traditional ways of product contributions and come out with something that works for multiple operators with one contribution.
The other, speaking to the question, on your, I think the first or the second sheet, the very last item on the bill of lading of what you need to submit is a test plan or a test procedure to show that the product actually meets a software test plan or something like that. That's how I understood it. Mm-hmm. I think
more of a manufacturing type test.
A manufacturing.
So if someone wants to manufacture that design.
Yeah, here's the test program, run it. So that's something that's a required part of the submittal.
Mm-hmm. And, there are contributions that don't require, as Archna talked about, design file contributing as well. So if someone wants to protect their IP and not contribute that, they can contribute a specification of the product that in this case would meet AT&T specification. And that product, instead of being accepted, would be OCP inspired. So that's another way that, suppliers and vendors, if you want to participate and your company isn't comfortable yet contributing your design package, and trust me, I understand that because it took a while internal in the company I work in. But there's a way to get involved and do OCP-inspired products and test the waters, and then perhaps in the future do designs as OCP accepted, if you'd like.
Did AT&T demand that you do the accepted path?
No.
Okay.
No. And I'm not sure exactly when AT&T was public about the Cellsite router, but back in Texas we talked about it. Many meetings, we've talked about it in the telco group, so it's not something that just happened in October. This has been something that's been ongoing for many months.
What did it take to make that mindset change to release the IP?
Many, many months. Yeah, it was just a lot of work, and finally getting to the point of trying something different. So it took me internally in the company I worked at, it took me over a year to try to get to the first time we did that and understand that it wasn't as scary as everybody thought.
So how long ago did you
Sorry.
Sorry. How long ago did you contribute your first fully contributed product?
In general?
Yeah, in general.
I think it was 5 years ago.
So
in the
you've had
network-
some experience with doing
Yeah, so we've been
it,
doing this for 5 years, right.
and the results are, nobody in your company has decided, no, we're not going to do that again.
Right. No, it's worked out very well. Not only commercially, but for the ecosystem as well. I mean, you have to kind of build the ecosystem as you go. So I think we've done very well at that, building the ecosystem and really, helping to get adoption underway. Okay, thank you.
Okay, hello everyone again. I'm back now with my AT&T hat on to talk about a couple specifications that we have in the broadband wireline area. So I think we have some newcomers here, so I would like to take a minute and kind of walk us through, what is it that I'm talking about, right? Meaning I'm going to be focused on two specifications. One is for the PON OLT, and then I'll touch upon a G.fast DPU as well. But before I get into the device, let me kind of give a brief overview of where we use these hardware in our network. It's going to be at when I say access network, it's the last mile that connects the subscriber to a central office. So that's the part of the network that I'm going to be focused on to provide broadband wireline service. And typically it's, we have two medium, right? Fiber and copper. So with fiber, the first one I'm going to be talking about is fiber, and we have different technologies that will provide gigabit service to consumers. PON stands for Passive Optical Network, and OLT is the optical line termination. And these are typically installed in central office, so that's where it originates, and PON will provide a point to multi-point, which means, using one PON port, you can serve multiple customers. And it really depends on how you implement. You can do, 32, 64, 128. It's up to the design the operator chooses. These specifications have been, like I said, have been presented before in the telco group. We have talked about it on the calls and previous workshops as well. So I'm going to be providing some key updates here. So let's start off with the PON OLT. What's the motivation, right? Meaning we do, like Jeff just mentioned, they've produced hardware that meets AT&T's XGS PON OLT spec. And so what drove us here is to another spec is obviously, meaning when you're trying to innovate and maximize, we want to have more port density. So that's the key. So increasing the XGS PON port density was one of the key driver. And then followed by, trying to future-proof for a next generation of PON. Today, we're mostly at GPON. I mean, like that's PMO, and we are starting to deploy XGS PON, which is a 10 gig by 10 gig bandwidth. And if you look at the standards in IEEE and ITU, they're already talking about 25 gig PON. I'm not saying that that's what the spec is about, but it's more of optimizing for an XGS PON, but at the same time, having the hardware capable of a 25 gig PON in the future when we move in that direction. As meaning in the data centers, when you have servers like compute, they get swapped every couple years, right? That's not the case in the telco. We tend to keep it for a long period of time, and the longer it's better, right? So these hardware, you can expect it to stay in our network for a long time. So that's one of the key, I guess, benefit for an operator to have that longevity. And more choice of silicon. I think we have heard this several times from several operators in the telco group that they would like to see this come through. meaning it's not to say that, we need like tens or hundreds, but I guess more than one silicon is always welcome in the open community. Programmable, just like the name says, this is made out of FPGA, which is a field programmable. So it is programmable and customization. Again, when I talk customization, right, meaning it's obviously an expensive deal. Anytime you want to customize, whether it's a hardware or, a silicon, it does get very expensive. And I don't think we want to go that far. But at the same time, you have an option if you want to customize. So when I say that, so for example, this box can do an XGS PON and then be upgraded to a 25 gig. In the future, I think we'll probably start to talk more about it, is you could even do something different in an access network or other parts as well. So it's basically giving multiple personality, if you will, to these FPGAs. So those types of evolution is possible. And I think we would definitely like to explore those options and see how it fits the different use cases for an operator. And then, optimized for SDN architecture, right? So, meaning AT&T, we are big on that, in an SDN architecture, trying to drive an open ecosystem with open hardware and open software. That's kind of what we are driving towards. And so this spec we'll talk about in the latest slides. When I get into the use cases, you will know more about the SDN architecture. And obviously, better economics, right? We're always struggling with that. So anything that will get the cost down for a number of ports, those are some of the key factors that drove us to do this design, or the specification, I should say. So let's look at the high-level overview of the main requirements. So this spec will do 32 ports of XGS PON, which is the 10 by 10, and with the future support of 25 gig. So this is pretty much like doubling what we have today from the 16 port to 32. So that is a big jump. We are going to be using the SFP28 because it needs to support both 10 and 25. And I think that's the same path IEEE is leaning towards as well. So that was an easy decision. In terms of uplinks, this will do up to 4 QSFP28. It's pretty much like 4 channels, right? 4 channels of 10 or the 25 gig, giving you the 40 or the 100 gig uplinks. Again, those are for redundancy if the operator chooses to use those links. The key here is also the next one is the no local aggregation. In our current design, you will see an aggregation switch inside the OLT. So that's going to be a difference in this design, that we make it optional. So that's one way that you get your 32 ports. But the spec is also going to be pretty broad, that it can cover different designs in the future. It's meaning 32 is what I think will get us based on the slides that I just talked about, it will get us all the benefits, but there's nothing limiting from doing a 16 port or a 24 port OLT with local aggregation if if an operator has a need for that. So it doesn't prevent, but then but it's, I would call it more of an optional part that you can have in the design. The next couple things are pretty much standard that we have today. We would want redundant and field replaceable power supply units, as well as fans. I have high efficiency, and then BMC and also optional CPU. These are pretty much what we have in the current design. So nothing new. We'll just reuse some of the components. And in the past, we kind of discussed about the hardware variant, what I mean is more of the physical form factor and what operators would like to see. I don't think we got a good idea of one versus the other. So I do have both options here. One RU, for a 19-inch rack, is pretty much kind of default, standard, right? We would want that available. And the second one that I'm highlighting is something interesting that we would like to see is the 2RU half-width sled that is designed for a carrier grade 19 open rack spec that we have in the telco group. I think it's yet to see, how many adopters we get for that CG19. There are a lot of benefits and efficiency with that design. So that's why kind of trying to explore if that would be a good hardware design. So this is a kind of a block diagram. I guess it's pretty boring as it's from an operator, right? You'll only see high level, and we would like to see more colors and more components from a supplier in the future. So what you see here is, the upper portion is pretty much kind of standard parts that we have in the current design, so nothing new there. And in the bottom is where you have the, the FPGA. This particular slide, talks about the FPGA with 8 ports of XGS-PON. So that will be the standard IP that comes with the FPGA. So it will do 8 ports highlighted in the blue box with the SFP plus and uplinks. So if you look at the left and the right, you will see more of a 16-port kind of a board, right? And on the right, again, another 16-port. The idea is to make it common so you can fit into the different physical form factor that you choose, whether it's a 19-inch 1RU or a sled. I'm going to show the design. And thanks to ADLINK for providing the pictures here. So here you will see, just keeping in mind the block diagram from the previous page. So though the 2 boards will just kind of go side by side for a 19-inch, the 1RU type, whereas in the sled, you can just stack them up, right? So you use the same design, same board, but then you're able to stack them up. Some of the advantages with, I guess the sled is also, since it's higher with 2RU, you're able to use better fans. So you get more efficient, and also, meaning if you look at the spec for the sled, there are probably a lot of things that you could reuse there. Again, hoping that will kind of simplify the design and also operational efficiency, how it plugs into the rack and the connectors and so on. Meaning that's more of a CG19, but having a sled design for the OLT would make it look like how you plug in servers, right? The compute servers. So these are kind of the 2 hardware variant, again, based on the use case. And if you have a central office that has the CG19, it makes sense, so that's why we all have both the options. So let me talk a little bit about the use case. So this is what we're looking at as the disaggregated virtual OLT. You may have seen these slides in the past, in different forms. So on the left is what we have today, or the access node, right? It's a monolithic access node with hardware, software, kind of bundled together. It will have, it has the PON-MAC line cards, the OLT line cards, along with application, your control plane, the network fabric, all bundled as one hardware in a chassis. And now in trying to disaggregate, and we just talked about what OCP is all about, it's a place to disaggregate, right, and innovate. So on the right is how we are disaggregating this box of the chassis of the OLT. From the bottom up is what you see, the PON OLT. That's basically what the specification is about. So that pretty much gives you the IOs that goes into a customer prem, right? So more number of ports, you're able to take, support more customers. And on the top or in the middle part is the compute servers. Again, those, nothing new, right? Meaning it's based on all the work that's happening in the data center. It's a lot of, we can reuse those components, those hardware. Compute server that can host the SDR controller, applications, all of the VNFs that we're starting to deploy. All those will go on general compute servers, nothing new, and an aggregation switch, or the top of rack that's kind of the network fabric. Again, we don't really need to reinvent anything in those areas because those are pretty much being used in data centers or cloud infrastructure. So when I talked about removing the aggregation switch from the OLT, it was mainly based on this idea, right? Because we already have an ag switch available. So it just makes sense for us to move towards a centralized aggregation instead of having aggregation in every OLT. So that's the idea, and obviously that will improve with cooling power and cost. So let's take a look at the software stack. The Open OLT box, as per the specification, would have the open interface to the Open OLT adapter to talk to Volta. What is Volta? So that's another open source project. It stands for OLT Hardware Abstraction, and this is primarily being worked in ONF, or the Open Networking Foundation. And we'll actually be hearing more about it in the afternoon session. There's going to be a presentation on this particular architecture, talking more about the software. So you'll probably learn more about that. But at a high level, what Volta does is, like I said, it's an abstraction, right? So it hides all of the information, or kind of the details of the PON function, and abstracts it. So you're able to keep your software stack separate, and basically you can innovate on both sides without really having the dependency, right? So any hardware that we get in just plugs right into the Open OLT. Open OLT adapter is also something kind of recent progress that was made in the ONF. Previously, I think they had different adapters for different hardware, and it was just getting difficult for new hardware to talk to this software stack. So what they've done is moved away from that, and now we have an Open OLT adapter that has those APIs open that can just fit into any of the hardware that plugs in, trying to make it as simple as we can, because these are pretty much very simple devices, right? And Volta will kind of provide it's sort of a mediation layer that will give access to the northbound SDN controller, so that way you're able to control and manage the hardware. And it doesn't mean that it has to be outside. It can be hosted in the OLT if there is enough compute, or it can be hosted in general, like an NFVI infrastructure. And that's kind of what we would like to see, with this, the design supporting that. And this is FPGA engagement model. This was provided by, we're collaborating with Xilinx and Fennec along with ADLINK on trying to come up with an engagement model for OCP. Initially, when we talked about FPGA, there was a lot of uncertainty on, how does this work with OCP, because it's generally, meaning we do have FPGAs out there today, right? But it's more specific to, the customer that they design it to. It has not been open. So here, trying to do a flexible IP with support for all of the XGS, the different variants of the PON, and future-proofing it. In terms of pricing model, it's going to be pretty much similar to the ASSP, where that's more of a standard part, right? So like I talked, based on the block diagram, the standard part would be based on an 8-port FPGA. So that would be, that's, I guess it's going to be bundled with the FPGA or with the silicon. Obviously, they will provide some customization if that's required. We do have some dates, and I would love to see these products come out with some early access by 1Q of 2019. So this is the second part of the update, and the OLT was more specific to the fiber, and now I'm going to jump to another one, which is more of the copper. GFast is a copper technology, but then using fiber, so you will take fiber deeper into the network, much closer to the customer, but then be able to use the last few hundred meters of copper to provide the service. So it can do close to a gig speed, especially with the second generation of the silicon. It should be able to do gig, meaning we are deploying the first gen today. So again, this is an update. We introduced this spec, I believe, probably a year ago around the same time. The update to this spec is on the Scipio specification and expanding the choice of the network processor that's in the design. So since we worked on the design, now we have more options available for the NPU. So it's really up to, I guess the supplier and the adopter to choose which one. So I'm just, providing an update so we can have more options here. Intel or an FPGA NPU and Ethernet networks has been one of the, supplier for the FPGA, and they've been working on, they've shown a lot of interest in this and made some progress. So that's also an option. This NPU is basically an integrated network processor with the PON MAC, since you need to, if you're taking fiber, especially PON, you need to have your ONU in the GFAS to receive the fiber signal. And also be able to support, it's a standard 999, it's basically an flow control for 10 gig. So previously, I think when we talked about the spec last year, we did not have that standardized. It was more of a 1 gig. So we've gone back to the ITU, and in fact, just a couple of weeks ago, it was consented for the 10 gig. So we made progress on the standard side, and we would just, we would want that to be included as part of this NPU, supporting that. It's pretty much like, meaning you have your receive and the transmit, right? So you don't want the transmission to send more packets than what you can receive. So that's kind of the flow control in order to avoid any packet loss and so on. And the key is also the power. It should be, reverse power feed, that's the RPF, is a key requirement for not just AT&T, but I think several providers in order to deploy it in the field. Because these DPUs can go, like I said, deeper into the network. It will be placed in anywhere in, for example, in a MDU in the basement, where you may have some power, but also it can be placed in outside plant poles, pedestals, and so on, where you don't have access to power. So reverse power feed is one way to power these hardware, pretty much using your customer line, the customer power, and via the customer line to provide to power the DPU. So it should be able to handle with single modem. So basically, even if you just have like one subscriber, we need to have the DPU on. So that's kind of the critical piece. Several suppliers have been working with to meet those requirements. That's the key. And the system block diagram is pretty much the same, kind of added it here for reference. You will see, no major changes. I've just updated the aggregation switch to be more common, so we can have, different options here. And, it uses the DFE and AFE. Those are the GFAST specific silicon for both coax or a twisted pair application. Okay. Use case here. So let's talk about, we've talked more about like a single DPU, and that's what the spec has been focused more on, how do you build a DPU. The way, I think, as we start deploying, we're finding out, there are other use cases as well that requires us to basically stack more than one DPU. In cases, it's more applicable to, like a twisted pair, where you have more pairs, say more than 40 or 48 pairs in a single binder, in which case you cannot have multiple DPUs because you're going to have crosstalk, right? So that's where vectoring comes into play. So we wanted to support up to 48 lines, which would mean 3 DPUs, since they're all 16 port each, stacked. So you're able to vector across all of the lines, all of the 48 lines across the DPU. And again, each of the DPUs will have to be also reverse power fed. So that's a critical requirement. And using a single SKU is the preferred method for us. We don't want to have like dealing with like multiple SKUs. In terms of uplinks, meaning I do have it as a shared uplink or dedicated. Meaning the design kind of calls for a dedicated uplink to each DPU. It was interesting to note that Ethernet had a proposal to have shared uplink. So if that makes sense, why not? If I can share it, it's better. So the next couple slides, kind of more of what I've heard from Ethernet networks in the last few weeks on how they plan to support it. It was interesting to note that to have the high availability scenario, so where you lose one uplink, you're able to the other FPGA provide that. And that's through the interface that you see as the cascading interface between the network processor. So this is for 2 DPU, and like I said, I would like to see more for a 3 DPU scenario, which is kind of what AT&T is using. But again, if there are other operators that have more interest in an HA scenario, then that would be interesting to look at as well. And this is the kind of the features for the FPGA. High availability is one, and I think what I found interesting was also the bonding between across the DPUs, right? So you're able to bond any channels across DPU, and I think that's a very good feature in this one. Like I said, would really like to see a product that can do this with the 16 port and be able to do, like I said, up to 3 DPU stacking. I think that's the end. Take any questions if you have.
Does that last product exist with the bonding across any channels?
I have not seen one yet with the, you said bonding across the DPUs?
Yeah, across any channels, yeah.
Okay, let me see if Ethernet wants to take that question, because I have not seen the product, but in the slides, and I think they have something in BBFW, would like to.
Yeah, so right now it's in the works, it's not ready yet. It will be announced, I think, in March.
Okay, thank you. Okay. Any other questions?
Another question. Okay, on the earlier, on one of the presentations earlier, they talked about being OCP ready and having a data center that was OCP ready. And when you showed the disaggregation, you showed a vertical airflow server with the blades run like that, which is very common for outdoor cabinets of a certain vintage. And when you disaggregate it, the airflow direction changed from vertical to front to back, because you got fans blowing front to back. And so the cabinet design for a disaggregated application is going to be a little bit different from an airflow perspective. And so the question is there an OCP ready cabinet spec?
Sure. So I think what you're referring to as the disag I think you're probably referring to the chassis, right, with that airflow. So when you disaggregate, the idea is to use the rack system. So that's the CG19 is one of them, or it can go into any telco existing racks as well. So standard 19-inch racks would be fine. Okay. So these are all like 1RU server type.
I think one of the keys is that it's in the CO. It's not out in an external cabinet anywhere.
Right.
It's not the intention is for this solution not to go in an external cabinet out in the field and be temperature hardened and all that, but to be more in a CO based application.
Yep. Thank you, Mike. Yes, these will go in a central office. Yep. Okay. Go ahead. Can you have the mic on? Do you have the mic on?
Okay, hi. Is this going to eventually, with wide deployment, get you to a point where you want to consider a data center design for 19-inch racks, or no? Not.
I wouldn't quite call it a data center, because the environments that we have in a central office is different from what you will find in a data center, right? So it does need to be NIBS compliant, and we do have those requirements in the spec. Because when we talk deployment, it's not possible for telcos to convert all of these central offices into data centers. That's going to be very expensive. So our expectation is that it will go into an existing CO with the environments that's existing today. So NIBS compliance, all those will still be required.
Yeah, I think the locations, I agree with you, but I think the whole stack, the data center stack requires a lot of innovation for the 19-inch rack versus the 23-inch, et cetera, for the big clouds. And this is something we are interested in, is how do we build the same innovation technology on the 19-inch racks, regardless of location. Location could be the COs, it could be anything.
Right.
I was just trying to understand, for someone like AT&T, at what point will you get to the scale where you would have much more engagement on that, or how you think about it, that's all.
Right. We are definitely, working more towards, like I said, with open hardware and open software. Probably not at the level of maturity yet with all of the software going on, but that's definitely our end goal, right? It's going to be a matter of time, but we're trying to accelerate as much as we can. So, we're looking for collaborators in that area also. Maybe CG19 is one way to look at it, but I'm sure I think there are also other options available for us to start looking at. I see it more of a just speaking in general, right? It's more of it's a new area that we're all trying to get through, right? So there are a lot of challenges that we have to face. We are exploring and definitely learning more about it. So engagement is key. We are working with the open community on both the hardware and the software side to realize that very soon.
Thank you very much. Thanks.
Okay. If there are no other questions, thank you. Thank you for your time.
My turn? Okay, great. Okay, good morning. Wow, good morning. Okay, so what I'm going to be presenting, by the way, my name's Mike Moore. I work for Nokia. I'm the regional product manager for our airframe data center portfolio. I cover North America and Latin America. What I'm going to be presenting today is a couple of presentations that we gave at the Regional Summit in Amsterdam at the beginning of the month. One related to Open Edge, an edge server initiative that Nokia started that we're actually creating a sub-project off of. And the other one was kind of some feedback from some of our Open Rack V2 deployments and what we're doing there to try to create a chassis that is a little more installable in legacy data centers. Okay. So first off, Nokia, we are a platinum member of the Open Compute Project. We actually started this about 3 years ago with the adoption of a Open Rack version 2 based design for airframe. We had started with rack mount. We brought in open rack about 3 years ago, and now we're taking what we've learned with that, and we're trying to deploy an Open Edge based platform. So we are a platinum member, and we're also a open compute supplier, solution provider. And so Open Edge brings about a lot of variables that you don't really get in a traditional data center, a centralized or a regional data center. Those are very scalable. There's typically sufficient power, there's typically sufficient cooling, floor weighting, all of that is while there are some issues at times, they're typically fairly plentiful. As we're moving to the edge, we're going to see that there's very limited floor space. These are up to and including concrete shacks at the cell site. The thermal conditions, you're not going to have the same type of environment as you would in a traditional data center. So we're going to have extended temperature extended temperature ranges. And then also when you get out toward the edge, we also have much more of a variety of power options. Typically in North America, we deploy mostly negative 48 volt, to legacy telcos, and then 208 volt three-phase to most newer data centers. Although we're actually starting to see kind of an introduction of 400 and 415 volt into the U.S. markets as well. And then also you might run into one-phase power that needs to be taken into consideration, especially for some far edge deployments that might be MEC related, not necessarily wireless related. And so we took those factors into consideration. We also looked at some of the acceleration support that's going to be needed. Cloud RAN, obviously, we're going to need acceleration for that. But then we've also been working with some of our FPGA and GPU partners as well, where they may be wanting to do some advanced applications at the edge, such as facial recognition, video transcoding at the edge, machine learning, things like that might require some acceleration techniques. And so with all of those requirements and what we had learned from OCP in our rolling out of OpenRack version 2, the centralized power feed, the all front access, the toolless maintenance, and the vanity-free design, sorry about the typo, we basically resolved to come up with initially what we're calling the Open Edge design. And this is a chassis overview. And so we kept it as a 19-inch rack mountable box, EIE 310 compatible. It's 430 millimeters deep. And what that really gives you is the ability to fit into a 600 millimeter rack with enough room in the front for cabling, both the networking and power. We do have redundant power supplies, so it's up to 200 watts per chassis, and it comes in a variety of power options. And then we designed this basically with a 1U and a 2U slot in mind. And the 1U we can power up to 400 watts, and the 2U up to 700 watts. Cooling's all part of the compute units themselves, or the sleds themselves. So very much in line with what was done with OpenRack version 2 and the compute sleds. The chassis management controller, it basically monitors the power supplies and is also the interface to the BMCs. One of the things we wanted to do was at least attempt to take some steps at minimizing the amount of cabling. So the RMC will actually have a very kind of lightweight layer 2 switch as well that will communicate through the backplane to all of the sleds that are in the chassis. So that in effect takes up to 5 servers or 5 BMC connections, reduces that down to a single one. So besides the very lightweight Ethernet in the backplane, basically the only thing in that backplane is going to be power. Open Edge chassis itself, very simple construction, steel enclosure, mounting brackets, backplane assembly, power distribution board, and brackets for a 1U toolless design. There is no integrated user plane in the back, so we really don't have to worry about backplane obsolescence unless our BMCs require more than a gigabit of Ethernet at any point in the future. And and this also gives us the opportunity to really sort of decouple our networking and computing the same way that we had done with OpenRack. And in addition to this, just kind of going off script a little bit, this is a 3U design. We started this 3U design specifically to really fit in the dimensions of a baseband unit. And so anywhere that a typical baseband unit for 4G can go today or 5G can go today, one of these chassis will be able to go, right? So if you have room at the edge, room at your cell site, you want to add some very high performance computing to this solution, this is a solution that will plug right in. And not only that, but any enclosures up to and including outdoor pole mounted enclosures will be an option for a rack like this. Okay? And in addition to that, we've actually toyed around with a few other designs. You know, while this might be a great solution for a 1U server, it's not necessarily an efficient solution for an all 2U. So it's relatively easy to take that, you know, basically bend a little metal, and just with that, you know, that HCI connector, extending that, you could go from a 3U to a 5U to a 7U chassis if you know, had more, you know, optimal height configurations in mind. This is what at least what our initial release is looking like. And you'll see bottom left, we have the 2 power supplies, the 2 redundant 2,000 watt power supplies, the RMC, and then this actually has 5 1U half-width sleds. So we can do that in the initial configuration 5 1U, and at the same time we can do 2 2U in 1 1U design as well. And I'm going to get into the details of what these servers actually look like next. And oh, by the way, the conversion of a chassis from 1U to 2U and vice versa is really just a matter of a support bracket that that can go in between you know, between I guess the U number 2 and U number 3. So it is an all toolless design for making that conversion as well. Okay, the 1U server, it's a half width. It is a single socket design with to meet our thermal specs, which we're basically going to operate from up to 45C and actually up to 55C and some you know, for limited duration. That's basically in line with GR63 core. We're going with a 20 core Intel processor for our initial release. It will be able to support either the 621 or 637 to give you, you know, crypto acceleration capabilities if needed. And then, you know, it is a shorter design and a half width design. So the number of memory channels that we have are not quite as great as, you know, as traditional servers. However, we're starting to ship 64 gig DIMMs along with these servers as well. So, you know, the memory density continues to increase, you know, to give us still a pretty dense compute platform, even in a small form factor. This particular card can accept 2 NVMEs or SSDs, and can also take a PCIe full height half length and OCP mezzanine card. Now for the 2U, the difference between the 2U really is just the riser that we use that allows us to have extra PCI slots and extra storage if needed, and also the larger fans that I think was mentioned earlier. The larger fans give you, you know, and larger heat sinks can give you improved thermal performance as well. If you notice on this one, we're actually up to 250 watts with our TDP, so you know, this one might actually be able to run a little hotter than the 1U version. In addition to that, with the PCI slots themselves, we do support a full height, full length card. And you know, that's especially, you know, we have some accelerators that are based on, you know, on large DSP cards, big NVIDIA V100 cards. I guess, you know, so we can accommodate, you know, the you know, a very dense acceleration environment as well. And then with the storage, we also have the ability to you know, to create a little more of a denser storage solution with up to 4 SSDs. And I see some of those U.2s are coming in 7.68 terabyte varieties now. So, you know, for being out on the edge, it is creating a fairly dense storage solution as well. The rack management controller, as I mentioned earlier, it basically monitors the power supplies, monitors the BMCs, and is, you know, the mechanism for you know, for remote monitoring, remote management of the chassis itself. There's 1 per chassis, and we have, it's based on the AST 2500 family, and it's got a single gig E RJ45, and then two 10 gigs as well. So you give it a little bit of a variety on what your, what your uplinks can be. Rack installation, also in the first release, we're certainly designing this for existing cell sites, but it is something that can go into any 19-inch rack. We will have the rails available for the installation as well. And again, it's going to be an all toolless design for the rail installation. We'll talk on our thermals, -5 to +45, short-term to +55, up to 95% humidity. EMC specifications, safety specifications. This will be NEB seismic zone 4 tolerant. Actually, the first open rack platform that we commercialized, we also included NEB seismic zone 4 tolerance with that. And that design we have, I believe it's OCP accepted, right? OCP accepted in the rack and power group. And so that's one of the contributions that we returned back. I believe we also, our EMI shielding, I think, was something else that we had submitted. And obviously, I wouldn't be here if we weren't planning on contributing this back to the OCP. We did in the regional summit back at the beginning of October. We posted these drafts as well. The draft submissions are on the Telco Wiki for you to all take a look at. And we will be creating a sub-project called Open Edge that I encourage all of you to sign up and participate in. We're going to be coming out with the schedule here in the next couple of days. I think we're going to try to hit a fairly rapid pace with this as well, because the 5G deployments and mobile edge compute is a very hot topic right now. So it's important for us to get out ahead of this and actually offer a product that can truly be deployed to the edge, to the far edge, that has all of the the performance and specifications required by our customers. And so the other thing I wanted to cover was, by the way, any questions before we go on to, yes? Could you? It's okay. Yes, we are.
Can you press the little mic front? We can't hear it. Oh, it is green, okay.
Okay. Yeah, we are working with partners to produce and bring this product to market. Yes. Yes, they are. Okay. Any other questions? Yes. By the way, I wanted to know: do stripes? That's kind of half plaid. Does
That's
that count?
it's half, I guess. I don't know.
All right.
So your design contribution for the design files, is it going to include the RMC and any of your server blades, or is it just the sheet metal and the backplane?
The chassis specifications itself, we are going for fully OCP accepted. The RMC, I'm actually not sure about that. That's a good question. And then the server design itself, I know we're going for a minimum of inspired, and we may even go farther than that.
Okay, but your goal is for your chassis to submit enough design files so someone could create a server blade that would slide in and connect?
Absolutely.
Okay.
Not only a server blade, but sure, we're coming out with initial blades based on Intel, right? I mean, it would be great to see something based on ARM, open power. Some of the designs, like what I just saw for carrier grade, for the Open 19, carrier grade 19, a 2U switch product that could go in there. I think that would be a great contribution to have. The rack itself, the bottom row actually has the capability to put a battery backup unit in there. So something like a battery backup contribution, I think, would be fantastic. And then what else comes after that? Oh, yeah.
So when you mentioned about EPU backup,
Right, yeah, to go back and take a look at that real quick. Oh, here you go. So the bottom, and I don't have a pointer, but basically the bottom part of this design actually will allow you to plug in a BBU that could power, the rest of the chassis in the event of a power failure. Well, it is what you see, the HCI, well, the one with the HCI connector. That is basically the bus bar. That's the power distribution bus, and it has the 1 gig Ethernet for all the BMCs. No. This is actually this is a standalone unit. And just like OpenRack version 2, this is a fully front-oriented design. No rear access at all required, and that's especially important for the Cellsite scenarios where you may only have about 200 millimeters between the back of the rack and the wall. Yeah, that's the Facebook design. Yeah, Facebook does have a bus bar. Yeah, we took some of the best practices, but we didn't necessarily recreate OpenRack in an open edge form factor. Okay, yes. Oh.
Go ahead.
I'm curious to know, we do have the SIAD, right, that goes in outdoor cell site environment. So will these chassis be able to support, I'm not sure of the spec, the depth in particular. Would this be, meaning would you consider that in the design?
Yes, we actually have, I don't know if you were at the regional summit last or early this month, but we were actually showing this design in a pole mount outdoor enclosure. Okay. Right, so it's designed to fit into, common outdoor enclosures nowadays,
sure.
Or today.
Okay, so you could, pretty much fit in the SIAD as well then.
Oh yeah. And I know the whole concept of having a pole-mounted data center, I haven't had a whole lot of demand for it yet, but it is something that sort of spurs the imagination that if you wanted to take that compute, all the way out to the farthest possible edge, we have the capability of doing that with this.
And a follow-up, meaning, just curious, how you came up with this particular design of just a 3 RU. Was that to meet any particular, use case from an operator?
Yeah, there's a lot of factors. Well, for one thing, I've got one of the early prototypes in Irving, in our facility there. That's actually a 5 RU. And that weighs probably about 90 pounds, fully loaded. Not something that's necessarily easy to take out to a cell site and easily installed. That's definitely a 2-person job. This 3U will probably come in around, 55 to 60 pounds, right? Brings it much more in line with something that perhaps a single operator can do. Especially if you, disassemble and bring it in, it becomes even lighter. And also, this is the design of the Nokia AirScale baseband unit, right? So we wanted to make sure that basically anything that we're producing now for the cell sites for our RAN could be a platform that could accept the open edge product.
That's very good. I mean, I did see your chassis in the summit in Amsterdam, so it is good.
Okay.
Thank you.
Great. Yes.
Yeah, and the question was, you've got a 2U space on the right as well as a 1U space. Could the 2U space support a battery? Does it have the connection if you wanted to have a larger battery?
I do not believe the 2U space supports the larger battery, no.
Okay, thank you.
Yeah, back in the back. I'm sorry, I didn't quite catch that.
So on the CPUs for the SLEDs, do you have a requirement right now for VGA packaging, or are LGA packages
They are currently based on the Intel Skylake Xeon technology. Okay, hold on, wait a second. Let me get it right. We got a couple of guys from Intel here. The Intel Scalable family of processors, right? And so it's actually going to be a 20-core processor initially based on Skylake, and we plan on very quickly moving to the next generation once it's available.
Yeah, it's Mikko Suni here from Intel. So it's a standard Xeon SP socket. So the very same you have in any of the servers, 1U, 2U, 4U. 1 socket, 2 socket, 4 socket, so forth. So standard Skylake and the next gen.
Thanks, Mikko.
On Pearly platform.
Okay. Any other questions? Yes.
So on the RMC, you mentioned that it manages the other BMCs. Does it actively manage them, or is it just a pass-through?
It's really just a pass-through. I mean, even today, if you take a look at just rack mount servers, right? I mean, they just have a giggy, usually a 1000 base T Ethernet port to it, right? And that's what this is basically doing, is just hiding 5 Ethernet ports behind a layer 2 switch.
Now, is that some kind of commercial BMC package, software package? Or is that an open BMC that's running on this? Or?
Ours is currently based on...
commercial?
Yeah, it's certainly commercial.
Okay.
Yeah. We'd be happy to move to open BMC, but with the commercial concerns at the moment, the commercial package was the quickest route to market. And also, we're participating in the open RMC effort. So we've had one meeting on that. The difference between this RMC and the rack management controller we were talking about in open RMC
is the breadth of managed options. So in this case, you're really only talking about getting some power information back and forth, and then while it says it's a switch, it's really just a hub. I mean, it's a dumb distribution to those other BMC ports. And so it's a much more simple item than the open RMC, but we've had interest in from other open compute providers in providing an option for this as well. So we may end up with some options on this open RMC.
Yeah.
One more question on your environmentals. So you mentioned putting this pole mount and cabinet mount, but it's only -5 to +45. So the Cellsite router is much more of an extreme temperature range for non-environmentally controlled areas. Is this eventually going to get to that, or is this always going to be in an environmentally controlled cabinet?
Yeah, that's a good question. I actually took a note when you did your presentation saying that you're going to +60. At this point, it's going to be in an environmentally controlled cabinet.
Okay. So by environmentally controlled, though?
So these wall and pole mount enclosures have some
filter.
Well, filter, but there's air movement, right, that you wouldn't find in a place that your router may go that may just be a pedestal on the side of the street that doesn't have any air movement other than what's ambient, movement of the convection current or whatever, happens to be.
And this can be a little bit of a moving target as well, right? I mean, the +45C to +55C is based on putting a 20-core processor, in the server, right? I mean, if we wanted to dial that back a bit, we could probably, get a few more C out of it.
And let me mention one other thing.
Yeah.
So Mike mentioned that this is a new sub-project of the telco group, and the intention of this, having this as a project, a sub-project, is similar to, think of OpenRack V1 and OpenRack V2, what it became. So we're giving, based on our requirements that we've gathered,
here's a product that we're producing, we're making that product openly available, and it's a starting point for what will become the open edge, V2, essentially, right? So that all of these kind of questions, we can now take those in, bring, have the discussions that we want to have about that. It's just the beginning.
Yeah. One more?
For earthquakes protection here, I see. Are you
Yes.
testing the fully configuration?
Yes. Okay. Anything else? Oh, yeah, one way in the back.
Yeah. Is there any discussion about the software stack to support all of this, asset management, et cetera?
You mean from a data center infrastructure management point of view? Well, we actually support open interfaces, SNMP, IPMI, and especially we have a very much a focus on redfish development right now. All of our BMCs will be compliant with all three of those specifications. Nokia, we obviously have our own data center infrastructure manager, but it will easily integrate with anybody's platform. Okay, let me move on to our transport optimized 36OU version 2 rack. And so first thing, we've deployed a little over 100 racks, I think, in the last year or so in both North America and Latin America, actually worldwide. And we kind of had some valuable feedback on those deployment experiences that led us to the decision to offer a 36OU rack as well. And so a couple of things, the typical installation, they haven't really been huge at this point. Typically less than about 10 racks per site. We've had no greenfield installations up to this point. Everything has all been existing brownfield sites. And what's that has brought about is the requirement for us to adapt to existing environments, up to including modifying our earthquake kit to for certain raised floor environments, certain tile spacing, certain pedestal supports. Everything continues to be redundant. It's all redundant switches, redundant NICs, redundant cabling, power supplies, hard drives, everything. We haven't gone to a kind of a non-redundant environment where all the redundancy is really held in the software. Telco requirements such as NEBs still mandatory, and the installations are very customer specific. Transportation. So rack and stack is typically not allowed on site itself. So our integration facilities will fully integrate, fully cable, fully populate, power up, burn in test, and then load it into a shipping cabinet that is taken to the customer's location. The installations are all over the world. This 42OU is a little higher. It's 2,258 millimeters, which for the rest of us is about 7'4". And so, in that case, the pallet itself goes over and above that 2,500 millimeters that most air freight is required. And so it takes a special plane, more expensive. We've had to take the container, put it on trucks and ship it 400 miles to get to an airport that has a plane that could actually accommodate the shipping of it. Right, so, and transportation tolerances are still need to be according to NEBs. The site limitations. The fully equipped rack, the 42OU rack, is heavy. It's 800 kilograms, which is somewhere around 1,800 to 2,000 pounds. I think what we actually did our NEBs testing on was right at 2,000 pounds for the rack. Rack depth is limited in many locations. Older sites also have other limitations, such as the delivery path, the height of the door opening, elevator capacities, door heights, the loading docks, all of that needs to be taken into consideration, and something that is a lot taller and a lot heavier, we can often run into trouble that actually requires, taking this fully integrated rack and basically pulling out all the equipment so you can actually tilt the rack on its side and get it into an elevator or move it up to put it upstairs to get it to its end location. And so, with our site surveys, we've done multiple site surveys for dozens of different facilities. So we've had the opportunity to really collect, a lot of information on these varied installation environments and come up with, what we think is a little better solution. Power and cooling. Most of our deployments right now are negative 48 volt DC. We do have a number of 208 and 415, three-phase as well, but really the majority of them, at least in North America up to this point, have all been minus 48. Power cabling from the top and bottom is both needed. Original Open Rack V2 was really just a top power option, and so we needed to adjust to those demands, and also operate in a power budget that's a little more lean than a lot of our dense computing environments. The Open Rack version 2, it's rated up to about 25 kilowatts fully loaded. We have a lot of customers that their edge data sites, data centers especially, are more legacy in place, and they have 4K restrictions on them. We've actually gone in with a couple of customers, worked with partners to put in a hot aisle containment solution with additional supplement in-row cracks to create a kind of a dense cooling environment within their legacy data center. And then also the BBUs. While originally they seemed like a very good option, we've actually we haven't integrated those in any of our customer deployments up to this point for a number of reasons. So our typical rack level configuration, we've got the V2 rack separated into 4 separate zones, and with with a single common bus bar. With 2 bus bars. You actually have an option with this where you can have a single bus bar for the entire rack or 2 separate bus bars. And so with our dense configurations, we actually have 2 separate bus bars, top and bottom, each 12.5 kilowatts each. And like I said, the power shelf options, 208, 415, neg 48. And we allocate for you for the switches by default, and that's really for the switches, the cable trays, 2 leaf switches, cable trays, and maintenance switch. Okay. And then our configurations, we deploy with a compute block. We can deploy with a 3 JBOD block, a dual 1 JBOD block, or a compute with 1 JBOD block as well. Our most typical is the 3 compute blocks and then a compute plus 1 JBOD block. We had it set up originally where we had basically an all compute and an all storage, and that allows you to scale the storage and compute individually. Well, most of these small deployments, like I mentioned, less than 10 racks, and most of them are more like 2 to 3 racks. They don't really require an entire rack just for storage, right? So we were able to integrate those 2 together and come up with a slightly more efficient solution. So going on to our new proposal, it's just basically it's a shorter rack. We moved from 42 to 36. That puts us in line with a typical 42U 19-inch rack. It is still Open Rack V2 compliant. Open Rack V2 doesn't make really any mention of the height. It's really just width and depth that's considered in the power distribution. We will maintain seismic zone 4 compliance, so we'll be modifying our earthquake kit to also work with this rack as well. And it's going to be slightly less weight. It's going to be a lighter solution, which should alleviate not only the problems with the heights of doors and elevators, but also the issues with floor weighting. And so what we end up losing, we do go with a slightly less dense solution. Instead of the 48 servers that we can put in to a 42 OU, and these are the third width 2U servers. We can now do 39 of them instead, but still a pretty dense solution. Okay, and the most typical target configurations that we're going to have for this is really the 2 compute blocks, the compute and the JBOD, obviously the 2 leaf switches, and a hardware management switch. We also can, you know, basically by sacrificing the top 2 OU of the rack, we can also accommodate leaf switches in our pre-integrated design as well. And so in summary, you know, why we're doing this, transportation is a big thing. Physical constraints with the deployments, you know, height of doors, elevators, really drive this, and then also the rack and the weight concern as well. Last note, we will be applying for this as for an OCP inspired recognition, and we do plan on having this in the marketplace in 2019. So any questions on the 36 OU rack? Yes. Oh. Yes. Right, yeah. Yes, correct. Well, it costs more than rack mount up to about your 24th server. After 24 servers, you sort of spread the cost of the rack out over all the servers, and then the servers actually become less expensive. Well, we're really driving ourselves by the demands of our customers at this point, and right now the majority of our installations are negative 48 volt. 208, you know, is popular here, 415 in the rest of the world, and then we also have some customers that are looking at 400 volt DC as well. Okay. Any other questions? All right. Thank you.
May I request everyone to take your seats, please? We have a small schedule. While we wait for lunch, I'm going to invite Mitch Patton, Director of Wireline Access Network, to come up and give a talk on behalf of AT&T.
Thank you, Sumithra. Well, I understand I'm between you and lunch, so I'll make this brief. Lunch will be at noon, closer to noon, and you can eat in here in this facility. Good afternoon. AT&T is honored to host the OCP Telco Workshop here at AT&T's global headquarters in Dallas. AT&T is a platinum member of OCP. We've contributed several open hardware applications to the telco group for GPON, XGS-PON using merchant silicon and FPGAs, GFAST DPU, Open Fiber Distribution Hub, and the Universal CPE, and the most recent Cellsite Gateway Router. Many of our specs have been OCP approved, resulting in hardware built to meet our specification and available through suppliers. AT&T is collaborating with like-minded operators on hardware specifications with the goal to have a common system that can benefit the industry. We are very pleased to see Deutsche Telekom's recent GPON OLT spec contributed in this group. We're driving towards an open ecosystem using open hardware or white box solutions from OCP with open software in our access network. For broadband access, we've utilized Edgecore's Open XGS-PON OLT white box in our lab testing and previously announced a POC for our XGS-PON service. We are moving aggressively to make this deployable solution for SDN-enabled access network with field trial that started in October and will continue into 2019. Access space has been very closed in the past, and we have come a long way in disaggregating the hardware and software. AT&T wants to thank this group today for supporting our open hardware strategy and help realize the same in our network. We look forward to expanding the scope into other areas in the access network. This is a very good start, but unlike data centers, we are challenged with economics, hardware, availability, and choices in the telco space. In general, OCP adoption in the telco industry is still in its infancy. This is a good forum for suppliers and operators to explore and educate one another to help accelerate the realization of open ecosystem in the telco space. We're pleased to see the collaboration among companies, and we are heading in the right direction with OCP. We appreciate the work being done here at OCP, and thanks to the OCP community and the members for all the work that they do. Thank you.
Welcome back. Hope you all had a good lunch. And so for the afternoon, we do have 3 topics. We'll start off with the first one. It's going to be a remote presentation by Saurav Das of ONF. He's the Director of Engineering, and he's going to be presenting SDN-enabled broadband access.
Okay. Hello, everyone. I'm going to talk about SIBA, SDN-enabled broadband access. Thanks, Sumithra, for introducing me. For those of you who don't know what the ONF is about, the Open Networking Foundation is an operator-led consortium that at the very top has our operator partners and our vendor partners. And what we do is we build curated open source, what we like to call curated open source projects that are of keen interest to our operator partners. We start these projects and lead them to a space where our vendor partners can work with us in the development of the project and then take it into production with the operator partners. We also have a number of other vendors and operators that together build a very strong ecosystem for our projects. So one of those projects is actually the umbrella project. Our flagship project is what we call CORD, that you may have heard of. We've been doing CORD for the last 3 years. It stands for Central Office Re-architected as a Data Center. And the basic idea is that, well, for the operator customers, residential customers, mobile customers, enterprise customers, this traffic usually comes at first to the central office, but we want to re-architect the central office to look like a data center, leveraging the best of cloud technologies, SDN and NFV technologies, to essentially give you the economies of a data center, building all of this with commodity off-the-shelf hardware, whether it's merchant silicon and white box switching hardware to off-the-shelf x86 compute. We want to bring this economies of the data center to a central office, but in addition to that, bring the agility of a cloud provider to provide rapid services at the edge for these customers. So this talk is about SIBA, SDN-enabled broadband access, and the way we look at it is that it is a profile that is built on the CORD platform. And in order to explain SIBA, I would have to start by trying to explain all of these subcomponent projects that together build up SIBA. So the outline of my talk is very much like that. I'll start with a project called Volta that is about disaggregated residential access. Then talk a little bit about Trellis, which is a multi-purpose leaf spine fabric that we built. And then all of this gets built together on top of the CORD platform that we like to think of as a service delivery platform at the edge of the network. And then finally, I'll talk about how we build SIBA and the development of the work that has gone into SIBA for the last 6 to 8 months and the roadmap for it. Okay, so to start things off, let's talk about Volta, okay? So when you talk about typical residential access, you're all familiar with this particular picture, that at the residence, you have an ONU, which is part of a passive optical network. At the head end is the OLT that is sitting in the central office. Multiple such PONs and PON OLTs then connect to an Ethernet aggregation switch. And then that finally feeds off into a BNG that connects to the rest of the network for an operator. Okay, so this is the traditional residential access. And what we started to do in Cord was to start disaggregate the equipment in the central office. So first of all, instead of having a traditional OLT, they said let's just have the OLT MAC layer in pizza-sized boxes in the central office, and have that be managed by an external software that we call Volta. Okay, so the Volta or the virtual OLT manages and abstracts the entire PON. Okay, and instead of an Ethernet aggregation switch and a BNG, we said, okay, let's replace that with a data center fabric that provides the Ethernet aggregation that you're expecting, as well as the routing that you can get from the BNG. And some of the other BNG services can then be pulled out of the hardware and into x86 boxes. For example, AAA is actually handled by the Volta piece itself, and other things like VLAN termination, hierarchical QoS, DHCP server that can be handled by software sitting outside the box. For example, a virtual BNG that AT&T's Foundry had in Atlanta had developed some time back. So this is what we mean by disaggregated residential access. And instead of focusing on the BNG or the Ethernet aggregation pieces, let's first focus on the Volta itself. How do we disaggregate and virtualize the PON? So if you look at a typical chassis-based OLT, you will find multiple such blades in there, which you have PON MAC blades, right? And then other blades where the compute and storage is located. And then all the software that is required to run a passive optical network and have subscribers be authenticated and provisioned. All that software also runs inside the compute blades on one of these chassis-based OLTs. And of course, there is a backplane that holds it all together. So in Volta, we say that, look, let's just take these individual PON backplanes, right, and have those as pizza-sized boxes, and have that be managed by external software that we call Volta, that ultimately presents these GPON or XGS PON MAC blades, several of them, as simple quasi-Ethernet switches to the external SDN controller, where this software can then be implemented and have that work for all kinds of boxes. Okay, so that's the basic idea behind Volta. So essentially, it's a hardware abstraction for these PON MAC blades, so virtual OLT hardware abstraction. So how would this work? So let's say you have the physical OLT that connects to Volta. And so first Volta reaches out to the physical box and says, okay, hello, why don't you tell me who you are? And then the OLT responds by saying that, okay, I am this OLT and I have these NNI ports, I have these PON ports to Volta. So this is the discovery phase. Volta then goes ahead and creates this so-called logical switch representation. And you will notice that the NNI ports are represented in this logical switch, but the PON ports of the OLT are not, okay? And I'll explain in a second why that is the case, okay? So further, this logical switch representation is then presented to the SDN controller, okay? Then later, when an ONU gets discovered on the PON, the physical OLT will also tell Volta that now I have another port in here that actually represents the UniPort on that particular ONU. Okay, so the internals of the PON, that is the PON ports on the OLT, the PON facing ports on the ONU, the actual OMCI that goes on between the OLT and the ONU, all of that is actually hidden from the SDN controller. Okay, so Volta is essentially presenting an abstraction of the entire PON as a simple quasi-Ethernet switch. So that representation is key. So as you can see now, another ONU has shown up that just results in another logical port on this logical presentation of the PON as an abstracted logical switch to the SDN controller. So all those implementations of the services that are needed for residential subscribers, whether it's DHCP, whether it's multicast, or whether it's VLANs that are assigned to a particular subscriber, all of that does not have to know about the internals of the PON, does not have to know about the clone messages, does not have to know about OMCI. So that presents a simplified abstraction of the entire PON to the SDN controller so that the apps written on top of the SDN controller can manage these services just like apps written on top of the SDN controller can manage a real switch that these OLTs connect to, okay? So that's the operation of, basic operation of Volta. This is what Volta looks like internally. It has these northbound agents that can talk to the SDN controller. Internally, there is a core that manages a bunch of adapters that connect to multiple different OLTs and ONUs from different hardware vendors, right? So the idea is that there is a common control and management framework that is shared by all these different equipment from different vendors via these adapters. And as I said before in the previous slide, Volta in itself hides the PON level details from the SDN controller and just abstracts the PON as a quasi Ethernet switch, easily programmed by apps on top of the SDN controller. So with very wide relevance to the Open Compute project, AT&T has submitted open hardware specs to the OCP. One such spec was for an XGS PON, the PON MAC layer that we had talked about. This was manifested into a box by Edgecore, known as ASF Pulse 16, available last year. And we and ONF, with its community in the Volta project, we built the southbound adapter in Volta for this box. In fact, we not only build the adapter, but also the software on the other side that goes inside the box. We call it OpenOLT, and we use gRPC to communicate between Volta and the hardware. So this was also available since last year. We've improved it actually this year. And the OpenOLT adapter and the OpenOLT software is really important to us because we have taken great pains in easing the onboarding for new vendors, including white box vendors. So the basic idea is that if you're a new vendor, if you are a different vendor and you want to integrate with Volta, all you have to do, you don't have to know about Volta core, the details of the Volta core. You don't have to know about how the SDN controller is operating. All you really need to know is that you need to implement this gRPC interface between Volta and your box. So you can just replace the software in your particular box. You can use this example that we have that is in open source, and you don't have to care what's above it. You just have to implement this particular interface. And we have seen that many such vendors have now integrated their hardware with the OpenOLT software on some variation of the OpenOLT software. So that includes vendors like CIG and Ispertel, and more recently, Tel Labs. And I'm sure there will be more in the future. So open hardware, which is the Edgecore OLT, open source software that together makes a white box, but also there's equipment from multiple vendors, even traditional networking vendors, that have now integrated their hardware with Volta. And a similar thing has been done with the ONUs, because we have open source software adapter called the OpenOMCI adapter that was contributed by AT&T and Adtran, and together with that, we now have a number of ONUs that have been able to integrate with for both the OLT as well as the ONU. So this is the time that I wanted to spend on to explain Volta. And I'll tie this all together when we start talking about SIBA a little bit later in the presentation. But next, I'd like to move on and talk about trellis, which is what we call our multi-purpose lead spine fabric. So in the previous, well, not in this picture, but a couple of slides back, we had seen that the OLT or a number of different OLTs can then connect upstream to an aggregation switch. That aggregation switch is part of, it can be a part, can be just a single switch, or it can be part of a larger fabric, and that fabric is also SDN controlled. We call it trellis, and we call it multi-purpose, and it'll make sense in a couple of slides why we call it multi-purpose. But essentially, again, with great relevance to the OCP, we build this on bare metal hardware, okay, and open source software. Again, the theme here is white box equals both bare metal hardware with open specs plus open source software, and that's what makes it white. And it's built on SDN, it's built on ONOS, so it's also SDN based. So if you look at the features that Trellis currently supports, there's a number of features that you would traditionally find in networking fabrics that are built for data centers. They will handle bridging, they will handle routing for both IPv4 and IPv6. IPv6 less common, but you'll find that in data center fabrics. You will have the ability to dual home to compute nodes and routers and so on. And there'll be multiple stages of leaves and spines and more spines, right? But what is not very common is that when you're building a fabric for central offices, you have to deal with a lot of different kinds of traffic that are coming from the customers of these service providers. So, for example, you have to deal with maybe MPLS traffic in one case, or the need for Q&Q traffic that is, say, typically coming from residential subscribers, or GTP encapsulated traffic that is coming from mobile subscribers. Okay, you have to either deal with DHCP L2 relays or DHCP L3 relays. So there is a number of these features that you won't find in fabrics that are commercially offered from multiple vendors. But in the Trellis open source fabric, we have implemented these features that can deal with all these different kinds of traffic that are coming at the edge of an operator's network. So today we support multiple ASICs. Typically they're the Broadcom based ASICs, whether they are the XGS, the Trident 2s, and the Tomahawks, but also the Dune chips from Broadcom, which are commercially known as the Qumran, and in the future Jericho chips. And we have this on the Edgecore equipment, as well as from QCT, and very soon from Dell. So we will have all this support. We also have preliminary support for Cavium's X-Line switches and P4-based switches from Barefoot. So this is what it looks like. I've told you about the hardware. I've told you about the features. But if you look at the software stack that we run inside, also OCP has a huge relevance over here, because we use Open Network Linux and ONI. That this all comes from the OCP. And in addition to that, we use software that comes from Broadcom that is known as OFDPA. Okay, you've heard of many different APIs that are built, like OpenNSL is another API that is built on top of the Broadcom SDK. So these APIs are open. OpenNSL is open, so is OFDPA. It's a different API from OpenNSL. But this is what we use, because we can then stick an OpenFlow agent on top of OFDPA, and that is then what talks to the external controller and presents an abstraction of the underlying ASIC to the SDN controller. That abstraction looks something like this. So even though the pipelines in a Trident-based switch, a Trident Tomahawk-based switch, is very different from the pipeline that is in a Dune-based, Qumran chip, the abstraction that is presented to the SDN controller is the same. And this is what it looks like. So This is why we use OFTPA, because it really just enables the SDN controller to be able to program all these forwarding tables and groups, whether it's Ethernet or IP, whether it's multicast or unicast IP or MPLS or the VLAN manipulations that we can do. We can do load balancing using layer 2 or in layer 3, multicast, flooding, all of these features from the ASIC, irrespective of the actual pipeline ASIC, it's projected to the SDN controller with this kind of an abstraction. So that's why we use OFTPA. And one other thing that we are doing is that we already have support of these Broadcom hardware using OFTPA in the SDN controller, where we have implemented multiple such applications to bring out all the features that I had shown a few slides back. But what we are now doing is that we are taking these and changing the southbound to work with these P4-enabled hardware. So instead of using these southbound, we can now just implement a different driver and that uses P4 runtime and say GNMI to talk to these P4-capable hardware. And the way we have architected this is that the same set of applications with all of the features that I had mentioned a few slides back, they will just be able to use different southbounds to talk to different hardware and bring out the same features, right? So we had, and the beauty about the P4-based devices is that we can implement additions to the pipeline in these P4-capable hardware to bring out new features in the hardware. So that is what we had demonstrated at MWC earlier this year. We had shown that the ability to take GTP encapsulated traffic and encapsulated and decapsulated, so basically traffic coming from mobile subscribers, can be handled all in hardware just by implementing that as a P4 configuration that gets downloaded into the P4 hardware. That new table is created, and then these apps can just take advantage of the new additions to the pipeline via this southbound. So everything that had come before remains the same, plus we can add this new capabilities into the P4-enabled hardware. Okay, so now I've talked about Volta, about the PON, and then multiple such PONs connect to the hardware. Switches that could be OFTPA-based or P4-based. So that's what I wanted to talk about Volta and Trellis. And now let me spend a couple of slides to talk about the Cord platform. I'm sorry, I'm suffering from a cold. So let me now talk about the Cord platform, which we refer to as a service delivery platform at the edge. Okay. So just a couple of slides. Cord has undergone a massive change this year. In July of this year, we released Cord as a set of Docker containers, essentially, okay? A set of Docker containers where we use Kubernetes to manage these containers and install those services with using standard tools like Helm charts. So this is what it would look like, right? You have these bare metal servers, and they are physically connected to, say, either one switch or multiple switches in a leaf-spine arrangement. So this would be Trellis. And then on one side, it's connected to the access nodes, so your OLTs, your PONs. And on the other side, it's connected to the upstream network, which is your backbone networks, right? So the job of implementing Cord is very simple. Choose your own OS, okay? In the past, Cord used to say that you have to use this specific OS, and we used to have a lot of problems with operators who wanted to use their own OS versions that they had hardened and had passed through their security measures and so on. So we have eliminated that step, right? So now an operator can use whatever OS they want to use, and on top of that, they can use whichever version of Kubernetes that they want to manage it, right? So Cord is not involved in this process. So for example, you can say that Archna is a project that has come out of AT&T, and Archna can then be responsible for downloading and installing the operating system on the bare metal servers, installing a version of Kubernetes on it, and Cord has nothing to do with that, right? So cord, therefore, can then be installed on top of Archna, right? So the basic idea behind the core platform software is that here's what you need for the platform. You need your SDN controller, you need XOS, which is what we use as a service orchestrator, and then we use a Kafka bus to communicate between the two and internally as well, okay? And then it's optional, but you can also use a monitoring stack that we consider as part of the platform. But if, for example, Archna has its own monitoring stack, you're welcome to just use that. And so it's optional that you put the core platform's monitoring stack on top of your installation. Okay, so this is where we are, right? This is what the core platform needs. And in addition to that, we need a certain profile that you implement on top of the core platform. So, for example, if you're working with SIBA, okay, clearly it's for residential access subscribers. And so that means that you are going to need, so once you load the SIBA profile on top of the core platform, you know that you're going to need Volta, right? Volta is to manage the PON and present it as a quasi-Ethernet switch to the SDN controller. You also need to establish a certain workflow, right? So SIBA, as it is designed, and I'll come to that in a bit, SIBA as it is designed can, using the same set of components, can implement multiple different workflows depending on what the operator needs. Every operator has slightly different workflows, and I'll come to that in a bit. So the profile will tell you the components that you need, like Volta. It'll tell you the workflow that you want in a particular deployment. And in addition to that, there's the set of applications that must run on ONOS that implement that particular workflow for that operator. Okay, so net, this is a very quick view of the core platform and how it's installed, how it can be installed on different platforms, like, for example, Archna, and how you bring about these edge services according to the profile and the workflow that you want to bring in. Okay, so finally, you would need the runtime configuration of this system, and then the service instantiation, of course, for the residential subscribers, right? So finally, we are in a position where I can tell you about SIBA. Now that we have talked about many of these components, whether it's Volta, whether it's Trellis, whether it's the core platform itself, okay? So the SIBA is built on this new core platform. So we have Volta and ONOS together managing the PON, right? And then that connects to these aggregation switches. Could be just a single switch, could be multiple sub-switches that let the subscriber traffic is, once it's managed by Volta, it never actually goes to the control plane, right? So the data plane traffic goes directly through the ONU, the OLT, the aggregation switch, and to the external world, whether that's a BNG or an external router, right? And we have another layer of software where we have what we call the network edge mediator. And it's the reason why we call it that will become very apparent very quickly. But part of the network edge mediator is XOS, which we have used to orchestrate the certain profiles and the workflows of this pod. And we call this entire installation as a SIBA pod, right? So to the external world, for example, so it could be ONAP, for example, or it could be a legacy OSS or an OSS system from a different operator. The idea is that you build these little local adapters to the SIBA pod to then work with whichever different OSS system you have from multiple different operators, right? So in the SIBA pod, for example, this OSAM local piece is called Abstract OLT that was developed by the AT&T Atlanta pod. For it, Abstract OLT is the local adapter in the SIBA pod to make the SIBA pod acceptable to ONAP, right, via OSAM Central. Okay, so in short, all this control software that you see over here, again, as I said, this is a collection of about 30 to 40 containers that are implemented, are installed in these compute nodes, right? So this is sort of the hardware layer, right? The OLTs and ONUs, the aggregation switches, the compute, and all of these software is managed by Kubernetes as about 40 to 50 containers running inside these compute nodes. And then, so this part can then be represented to external OSS systems, okay? So I was talking about workflows. Workflows is a very important concept. So AT&T has a certain workflow. It wants, authentication to happen for the RGs using 802.1x before a DHCP address is assigned to the residential gateway. And that DHCP assignment needs to have DHCP layered L2 relay up to the BNG, which is external to the pod, right? So this is a certain workflow that AT&T has. But go and talk to a different operator, and they'll say that, look, we don't do 802.1x based authentication. We do DHCP based authentication. Go to a third operator, and they'll say, yeah, we don't do either of those. We need PPPoE based authentication. So as you can see, it's the same set of components, but the behavior of the components changes when when it's deployed at a certain operator. So that's why what we have done in SIBA is to have the capability to implement multiple different workflows. Okay, so it's the same profile. It's still meant for residential subscribers, but has different workflows. And depending on the workflow that is chosen, it might result in different applications that are run on top of the SDN controller. And it might have different logic to allow one operation to happen before the second that needs to happen before the third. Okay, so the workflows concept was introduced in SIBA. And the other thing that was introduced was these FCAPS capabilities. So we have a whole monitoring infrastructure in SIBA, and you can see this, it's based on all of this information coming from not just the pawns, but the aggregation switch, and from the actual software that is running inside the compute nodes. All of that information feeds through multiple interfaces, but mostly on a Kafka bus, sometimes using REST, sometimes using more specialized interfaces like the Redfish APIs that both the OLTs and the compute nodes support. But the idea is that this information, say statistics or many of the pawn alarms, whether they are ONU alarms or OLT alarms, that all gets fed up to Volta, which then puts it on this Kafka bus and then can be consumed by the network monitoring infrastructure. Now, as I said, this stuff can come from both the aggregation switches as well as our internal software, right? So ONOS itself creates logs and events that too feeds into the Kafka bus. XOS, the service orchestrator, also feeds information into the Kafka bus. So you can have this one place where where we use an Elk stack to display logs and events in Kibana or statistics in Grafana, and all of that can be self-contained, or it's optional. So the cord control software, platform software is very modular. If you choose not to consume it inside the cord pod, you also have the ability to export all the software from Kafka. Export all of this information via Kafka to the external operators. So imagine if it's deployed in AT&T's network where they have ONAP running and they just want all the raw information that can just be exported to ONAP from a SIBA pod, and then ONAP can work on this raw information. Okay, so we did a demonstration of this work last week at the Broadband World Forum in Berlin. One where we showed the NEMS user interface, as I was telling you about. The AT&T workflow driver implements AT&T's workflow, where you would want to have some authentication of RGs followed by the DHCP stage using to relay and so on. There is some concepts of whitelists for ONUs that are allowed into the network, and if they're not allowed, if they're not in the whitelist, they won't be allowed. They'll be disabled and disconnected from the network. So, and then together with inventory and the status of various steps in the workflow, all of that is seen in the NEMS user interface. And then the monitoring infrastructure, I've only shown Grafana over here. We also have Kibana for the FCAPS capability in SIBA. So like I said, this was our demonstration at PPWF. So right here you have the network edge mediator. Like I said, it has the workflow capabilities and the orchestration of the workflow together with the monitoring infrastructure, and then information is fed up and then controlled via the SDN controller and Volta to manage the PON. One of the highlights of this demo was that we showed integration between OLT vendors from a number of different vendors. The Edgecore OLT, which is the white box OLT for XGS PON, where we as ONF and the community writes the software that goes inside the box, as well as vendor OLTs like from Adtran, who's one of our partners, CIG, and Iskratel. In fact, for Iskratel, we showed both XGS PON OLT as well as a GPON OLT, and then that all is managed by Volta. And also a number of different ONUs, also from a number of different ONU vendors, all being managed and abstracted by Volta to the external SDN controller and managed by NEM in this SIBA pod. Okay, and if you're wondering, we also have the ability to, we're still in development phase for this, but we have a simulator that simulates a PON. And in fact, it can simulate tens of OLTs and hundreds of ONUs, and that's basically a way to stress the software inside the pod and see how well it scales and performs. Okay, so this is what our pod looked like. As you can see, there's a number of ONUs from a number of vendors, a number of OLTs from a number of vendors, and they're all physically connected to this aggregation switch, which is also from Edgecore. And down here are the three compute nodes where we have all of our control software, basically about 40 to 50 containers managed by Kubernetes to control this pod. Okay, so very quickly, I want to tell you a little bit about the history of this work. Mostly SIBA was developed through this year with a joint collaboration between ONF and AT&T, but we also had a number of different contributors. We couldn't have done this without our community. We have a number of different contributors as part of the SIBA and Volta community, whether it's OLT, ONU vendors, or software coming from Broadcom, from Adtran, from NTT that helped build the simulator. There's software that is coming in the future from Sienna as next version of Volta, and also Radisys and Netsia that is working on integrating this work at various different operators, and also with ONAP using OSAM. This is the work that Netsia is working on. And let's not forget the work that QA and test is required. So we have a community built around doing test automation as well as certification. ONF itself does I lead the team that is responsible for a number of different things, right? It's the joint development, whether it's daily scrums, bug fixes, design discussions that happen with the AT&T Foundry and the community. We support SIBA, we use weekly meetings. We have our Jira and our mailing list, and we answer questions on the mailing list. So we support the community that way. We're responsible for developing a number of new features, including the workflows. We look at stability of SIBA and Volta, and also are focusing in the near future on performance and scale. That's why we are building the tools in order to, like the simulator I just talked about, we're building the tools to allow us to measure and see where things break so we can fix it. And of course, we also have a QA team and the extended community that gets involved in automated testing and certification. So these are all the responsibilities that the ONF manages on a daily basis to support the SIBA and Volta community. Our deployment goal at AT&T, of course, is for a SIBA pod to be managed and operating with AT&T's external BNG with a number of services that are accessible through the SIBA pod via a couple of software that is added to the software that already goes inside these compute nodes. So one of them is that abstract OLT that I was talking about, which is like a local adapter to the SIBA pod specifically for AT&T so that ONAP can talk to this particular SIBA pod. By the way, I say specifically for AT&T because definitely it's used in AT&T, it will be used in AT&T, but if the same abstraction and a software is required by other operators, they too are welcome to use the abstract OLT, again, open source software that to communicate with the SIBA pod. And on the other hand, there could be some operators that don't want to use abstract OLT and go directly to the SIBA pod using the NEMS northbound interface, and that's fine as well. Okay, so very quickly on the roadmap, we have disaggregated the PON, the aggregation switch, and some of the features of the BNG, but not all of them. And very important feature that is missing right now is the ability to do hierarchical QoS. That is something that we will be looking into together with our partners from AT&T and Deutsche Telekom. So we're very interested in doing BNG disaggregation as well. And using P4. So I mentioned earlier in the presentation that Trellis has the ability to now work with not just TPA-based southbounds, but also P4. So we want to use P4 in the aggregation switch to implement certain features in P4 switches that will allow us to do this BNG disaggregation even better in the fabric. We do want to implement more operator workflows. We have a recent submission of an operator workflow from Telecom. We look forward to implementing that one as well as other workflows, say from Google Fiber and Deutsche Telekom. And of course, we need to look at performance and scale improvements for our trials. Redundancy is another factor that we need to look at. Some of the components that are in the current SIBA pod are redundant, some aren't. We just, not because, independently as a project, they are redundant, but we haven't brought that feature into the SIBA pod yet. So that's what we're doing. That's what we're going to do in the near future. We do want to integrate Volta 2.0. There is a lot of changes that are coming to the Volta code base, including Volta 2.0 and technology profiles, which is a way to make Volta work with not just GPON and XGS-PON, but also with other kinds of access technologies like GE-PON and G.fast and so on. So in-service software upgrade is a very important feature that we still need to work on. And finally, to be able to take other profiles. So far in this presentation, I've only talked about the residential profile, but there is really no reason why other profiles, like for the mobile subscribers, cannot work on the same infrastructure that is used for SIBA. That will then allow the SIBA infrastructure, right, the PON itself, to act as a mobile backhaul for base stations to connect to the central office. Okay, so to summarize, ONF is an operator-driven organization that produces curated open source, and CORD is our flagship sort of an umbrella project, and the SIBA exemplar implementation is built on the CORD platform as a profile of that is installed and instantiated on the CORD platform. The components I've talked about, we've talked at length about Volta and how it abstracts the PON as a quasi-Ethernet switch to the SDN controller. Trellis is the multi-purpose leaf-spine fabric to which these the Volta managed ponds can connect to. They are both compatible with OCP-based hardware, both Trellis and Volta. And then Cord is a service delivery platform, a set of Docker containers that is managed by Kubernetes, on which all of this control software is installed and managed. And finally, CBA itself, it's, like I said, it's a profile that is instantiated on Cord. It's jointly developed by ONF, AT&T, and the CBA and Volta communities. It also involves this network edge mediator that allows you to build these local adapters that can then take the CBA pod and have it be managed by the OSS from multiple different operators. We have a significant focus on the FCAPS infrastructure in CBA, where all of this information is fed into the Kafka bus and then displayed using Grafana and Kibana. Or if you choose, you can have it further be propagated to the external OSS. So there's other software that can manage, but all the work in generating and having all this FCAPS information was a significant work that we had done in CBA. And I also talked about different operators having slightly different workflows. So the ability to use the same systems, but to adapt to different workflows is something that we have made a focus in CBA. As you know, it's headed to trials later this year at AT&T, and there is tremendous interest from operators worldwide, really, in CBA. So that's all I have, folks. Thanks very much for listening. I'm not sure, Sumithra, if there's any question-answer session.
Sure, we could do a few minutes of Q&A. Any questions in the room? Okay. Looks like I'm not hearing anything, Saurav. Thank you very much for presenting.
Thank you.
Good afternoon, guys. So my name is Jeff Sharpe. I'm the strategist and business development prime for a company called ADLINK. And I want to do a preamble before I kind of go into all the slideshows and all that. Two things. One is I want to thank AT&T for hosting this. This is a beautiful place. Great seeing a lot of old faces, Craig, a lot of the Nokia folks. And one thing about our friends here at OCP is we've been members for 4 years. We started off as a gold. We're now a platinum member. And as a manufacturing, as a hardware supplier, also getting in more and more software, the greatest thing about OCP is that we can pick and choose different common architecture sleds, formats, NIC cards, things that we can put into our system that is not proprietary in nature. We see the operators, we see the market moving more and more towards an open architected environment, starting off in software, but really pushing that hardware commonality into the market. And for us, working with AT&T, we bring a lot of value. They bring a lot of value to us. We're also working with other carriers that they may not know that, you know, a Telefonica or an Orange or a Deutsche Telekom may be wanting to do something the same. And as a hardware manufacturer, working with ONF and other software architectures, it's good to pull all this together. And OCP is such a great venue to share the resources, share some of the information, because when it's all said and done, there will be a common architecture being deployed. Within ADLINK, we support many different market verticals. I have one of the best jobs in the world. I'm the telecom wireless guy and transportation guy, but we also work in the industrial IoT space. We supply into healthcare, military, and what we're seeing in this slide is we're members of all these different open architected environments, and a lot of them are really starting to converge. You have the FAW consortium, you have OMG, you have ONF, Cord, Acrano, all of these architectures are starting to mesh together, not just for the wireless world, but realize the military loves this stuff. They love hardware that's hardened. They love software architectures that's been proven in the industry. Industrial IoT, how I manage the stream of flow of data, is a lot of the same that we see in the wireless industry as well. So again, I have the best job in the world because I can see the whole spectrum of what technology is doing and all the different groups that we're part of. And one of the key things that I try to do, working with OCP and others, is try to cross-pollinate some of the information to make sure that, again, we don't want to build one product with 5,000 SKUs with all these different options. We want to use a modular common architecture that you can plug and play these different SKUs into on an ongoing basis. From a network and communication standpoint, great lead-ins from both Nokia and our friends at ONF. This is a complex system. A lot of times when you look at these different architectures, a lot of companies go after gleaming objects. So there's a new gleaming object a week almost. So what we're seeing is with this open architected environment, these gleaming objects are really starting to morph into one big, huge gleaming object that companies like AT&T, Verizon, Telefonica are all using. And I stole this slide from the OCP conference that was held in Santa Clara or San Jose in March, and highlighted the fact that, again, it's complex, but it's morphing down into a more solid element. And for ADLINK, sitting on the TIP project, Telecom Infrastructure Project, OCP, ONF, we're now joining Acrano as well for our edge-based programs. It allows us to really future-proof our products and see how all this stuff is being fit together. And the last presentation with the ONF guys, with Cord, it is complex, but it's starting again to get smaller and smaller into reusable products across the board. For edge computing, in my presentation, I'm going to do two things. One is what are the market drivers that we're seeing across the world? Number one. Number two is what are some of the new technologies that are being developed from the silicon providers like Intel and NVIDIA and Xilinx, ARM-based processors, how all these things come into place to better provide quality of experience for the end consumer and users, and also drive revenues for the operators as well as they're starting to tap into this service revenue environment. And you can't do it in a cloud. You can't offer a lot of these great services that are thousands of miles away. You really, really have to do it closer to the consumer. And Mike had a very, very similar slide with Nokia showing that as you want lower latency applications and services, the closer to the customer you've got to get. So with ADLINK, what we're doing is we're focusing through a lot of these open architecture committees, really from the local data center, which are now becoming central offices, all the way to the customer premise, and all the hardware in between, and then the software infrastructures in between as well to manage different products. Now, of course, as you're getting closer to the customer, every one of those environments have different environmental controls. You have central offices, you have NEBs, you have radio towers, which have extreme temperatures, you have outdoor plant, you have customer premises. You don't want to put a huge rack mount server sitting onto a desktop. So we have to look at the modularity of all these products and how they fit from the local data center to the edge, all the way to the access customer site. And within our products, our strategy is really taking a common-based sled or a common-based architecture and reuse these in all these different types of systems, which I'll go into more detail. As we're progressing into proof of concepts, working with customers on different use cases, again, you go meet a customer, you go with 4 or 5 use cases, and oh my gosh, you walk away with 25 use cases that are based on a common thread. So what we see is really 6 types of services that are really driven for not just network optimization for the carriers, but also how do the carriers make more money? How do they actually deliver services, especially with 5G coming down the pipe, at a very fast, easy access, cheap way their customers to do it. So I'm not going to go through all of these different use cases, but the key ones that we're seeing are things like firmware upgrades over air. We're seeing content delivery through media services, GPU technologies, augmented reality, virtual reality, industrial IoT. How do I deliver fast factories and smart factories and smart utilities using edge-based products? We're also seeing virtual CPE. You're seeing more and more customer premise gear being talked about for these services-generated activities. And location-based services seem to be kind of boiling up to the top, especially as we're seeing more and more GPS-controlled items, more location-based services that really require that low latency delivery. So if you think about it, if I am wearing some augmented reality glasses or Google Glass or some of the new things that you're seeing, and if there's a delay, and the brain actually manages a 12 millisecond from my eye to my brain, anything outside that's going to give me, I'm going to get seasick. So we want to make sure that the customer, the end user, will have the ability to drive these low latency applications. So recently, at the beginning of this year, we're great partners with Intel. We're a premier partner with Intel, but we're also looking at NVIDIA as well because of some of their GPU-based technologies and having the ability to deliver what we call an accelerated edge compute device or an appliance. And things like artificial intelligence, machine learning, high-performance compute attributes, HCI components, GPU virtualization, actually virtualizing applications or VNFs on the GPU, and also doing both real-time and low-latency-based analytics. And all these have to do with all of those different applications that need that low latency that you need to put at the edge. And again, that could be the radio tower, it could be a customer premise, it could be the central office, or anywhere in between. Also working with a lot of the ONF, the ONAP, Acrano, what we're also seeing, some of the prerequisites that are required for a lot of these edge products are things like self-healing and resiliency. You've heard of the terms carrier grade and HA, but now you need to understand that as they are sitting into a remote tower, let's say in Minnesota in the middle of February, as they progress and see that the temperatures are getting colder and colder, what do I need to do? Without having someone to manage that attribute. So if they also see an S1 link that's possibly fluttering, how do I actually invoke things like an optical bypass solution? Automation, machine learning, artificial intelligence, that GPU technology really enhances a lot of your x86-based technology as an add-on to really incorporate some of those great AI attributes. And you can't forget about the cloud native, all the things that are being done in the open architecture world by setting up these layers to be able to manage these applications on the cloud. And here the cloud could be that remote device. So all of that architecture, that hierarchy of software needs to be common throughout my network, not just in my data center, but also on the edge as well. So also, how do I do that with GPU-based technology? As I'm adding another type of silicon in there, how do I add more attributes on top of that software to enable that cloud-native approach on a GPU itself? And then, of course, open software, open architectures are definitely the foundation and the key of doing that. And committees like ONF, ONAP, Acrano, and OCP are driving down that road. So as a manufacturing company, this is my headache. So it's great. It's, I learn a lot. I get to see a lot of different technologies, but also realize that we have to put all this together either for ourselves or for our partners like Nokia, other system integrators. So you have ONAP stacks, you have Acrano stacks. We partner with Wind River for their titanium, NFV, and OpenStack. We have NVIDIA software platform as well that has Docker, it has GPU virtualization, it has all these different SDKs and tools to be able to produce the AI function. And then Rate Assist kind of helping put some of this software architecture together, especially for video and media delivery. So we have to have partners. And again, this is where this open collaborative environment, like OCP does, that we can talk to Flex, we can talk to Rate Assist and Nokia and really kind of combine our efforts to put a lot of this together where AT&T and Verizon and these others can rely and de-risk their deployments because of the integration models that are being put into place. A good example of partnerships is we're working with a company called Charles Industries. And as we see more and more 5G deployments, especially in a small cell environment, a picocell, we want to put more and more edge gear, like Mike said with Nokia, on these poles. So by taking these common elements that we've produced for OCP and other architectures, we can actually put them in these boxes and then submit that into the OCP form factor for openness. So Edgecore could put stuff in, Nokia could put stuff in, and all the different companies can put stuff into that container, using not just x86 technology, but NVIDIA, Xilinx, FPGAs, ARM-based processors, all within a common base on poles or in these central common environment vaults. One of the products that we're going to be submitting into OCP going into next year is our fanless server. So we have a dual Xeon processor that is in a fanless environment. It's an IP65. It's just a big old hunk of metal heat sink. So this is waterproof, it's fanless, it has 10 gig ports, it has dual Xeons, and we both support Xeon and the i5 architecture as well. So this will actually can be put directly out into the sun, out into the weather, on a tower or on a railroad station. And what we're actually seeing is really developed primarily for our friends at Nokia for their liquid server, but we're seeing a lot of interest in mining and IoT markets, transportation markets, and also military markets as well. So we'll be submitting this hopefully for an OCP certified program. Around the Accelerated MEC program, we've partnered with Rate Assist on the Open Compute Project carrier grade, which is a 19-inch frame infrastructure. Rate Assist built the actual 42U frame. They did the spec itself, working with Invent, Artisan, and ourselves. And we actually supplied the sled spec. And our strategy is to take some of these common sleds and have the ability to plug and play in either a 42U frame disaggregated structure or in a single appliance or as a MEC server like what Nokia is trying to do. With different types of, again, circuitry, different types of silicon partners, all from a 2U, 1U, all the way to a 42U form factor. And this is critical because as an operator, having the ability to purchase one SKU for a sled, but that sled could be put in different types of environments, we think is a very, very a good positive traction going into this open architecture. So as an example, as you see in a common architecture, you have the sled on top for edge data center for the big OCP carrier grade rack system. That has a bus bar in the back. It has Molex connectors. It's all a plug and play system. But those cards that are inside that box are the same cards that fit in all of these types of systems. And those systems can be placed at the radio tower, could be in the central office, could be in a data center. It's really the sheet metal, the environmentals, and how we validate and test these for NEBs and other functionality. And then all the way down to an access layer, using different PCI card slots, hardware accelerators. We can get into OLT, virtual OLT, we can get into switching. And by the way, all of these components here are all standard within the OCP-based platform. OCP NIC 2.0, the Olympus board is one of our full-frame boards I'll talk a little bit more about, and our OCP half-width sleds are all part of that as well. And then we'll see that continue to expand. For our NVIDIA-based program and our Intel-based programs for artificial intelligence and really generic GPUs or GPU for video, we actually came out with a development kit. We have 2 development kits that we're probably not going to submit into OCP because they're really built there for feedback from the market. An example would be we have a 4U server that can support up to 8 GPUs, and it's a monster. This thing is huge, but it's great to just put into the data center, work on applications, load up my stacks to see what those latency controls are on a very, very high-end based server, HCI server. We also have a smaller box, a 2200, which is a 2U form factor that supports 2 GPUs with an x86 core processor. And by the way, the motherboards on these are the Olympus-based motherboards. And we use the OCP 2.0 NIC to be able to support and the various other types of NICs, whether it's optical bypass or whatever in each of those servers. So as we progress into the first half of 2019, we're adding additional software stacks that we're in development with both Intel and NVIDIA, and also Kubernetes and ONF and others to actually deliver an infrastructure platform with APIs for those edge-based applications, and then also put it into a rugged chassis on the power pole or a telephone pole or whatever to be able to support these high-end GPUs. By the way, these GPUs, man, they're 300 watts. They pull a lot of power. So you don't want to have something that's going to really heat up the entire neighborhood for a system. And then as we progress going into the second half of 2019, based on the proof of concepts that we're part of and the feedback that we're getting, we'll actually build the sleds themselves, the actual architecture. NVIDIA has a thing called NVLink, which is like their approach to PCI that enables their different GPUs to be connected and look as one brain. So we're trying to figure out how to do that and integrate it into PCI and different form factors to go in. And we're really supportive of what Nokia is doing with their open edge and working with them on the various sleds. And Mike mentioned ARM and NVIDIA and all this stuff along with Craig and how we fit this together as a complete standard. And by no means do we want to compete with that standard. That's what OCP groups are all about, is that collaborative effort. From an NVIDIA, our phase 1 and our dev kit with the 4U based server and the 2U based server, along with putting this into a pole mount enclosure, is that it's not just the actual hardware itself, but there's a whole layer of software on top. So we'll support KVM, we'll support VMware hypervisors. Those VNFs can actually be placed on the GPUs, but we haven't seen a huge benefit of that yet. So as we start moving up with some of these SDK kits working with NVIDIA, we think we'll get better latency. And our target on this is around 10 millisecond round robin from a packet coming in. That packet could have a GTP header on it. We do something, right? We do analytics, we do AI, we do something with it. Put our GTP header back on, send it back, all within this 10 millisecond. And that's hard to do. So working with the different software partners, all the deep learning frameworks from Caffe, TensorFlow, Mix, PyTorch, all these are APIs and SDKs that we can add onto the system. So when we deliver this from a POC standpoint, this will be the software infrastructure that we're delivering. We also support the various types of, NVIDIA cards from, they have a new T4, they have a V100, a P40, and a 1080, which is a graphics card. But that graphics card can also do some deep learning activities as well. And these pull some power, as I said. So we want to build a system to be able to support these and then finalize it into a real embedded core product with NVIDIA. I had mentioned about these enclosures. So we're working with Charles Industries. This is their cube-based system. We're also working with Schneider Electric. They have a bring-in data center, like on a flatbed truck, which is about the size of a container, we can actually put the OCP CG gear in this. But for smaller deployments, we think this is great along with the CEV vaults, where these have battery compartments. They provide the power. They provide cooling. We're also interested in some of the liquid cooling attributes. And by the way, the liquid cooling piece is a new sub-program within OCP that we're part of. So looking at all these different types of technologies to really cool these systems, because they're going to be generating a lot of heat, they're going to be generating a lot of power, and we want to make sure that we meet the thermals and all of the requirements that the operators provide. We also have a new product. So we started a product that was really built for a manufacturing environment, high-speed lines. Foxconn, as they're producing the iPhones, taking pictures of all the components going across and doing analytics, making sure nothing is broken within that manufacturing process. So what we've done is we've taken the Neon J. We have a Neon I, which is the Intel. Now we have a Neon J that has a Jetson embedded into it. And with that Jetson embedded, we have a 1080p. So you can actually do inferencing or AI technologies at the camera in different locations. And this is IP65. It's outdoor. It's waterproof. So you can actually do intelligence right there at the edge using this camera. And we'll probably be submitting this as an inspired OCP project, this and our Intel base, which will combine a camera and some of the software on top of it. And then finally, because we are going across the board with a lot of our AI-based products, I talked about our Tesla accelerated MEC program on the right, but we also have Jetson array servers. If you don't want to put an intelligent camera, you just want to use closed circuit TV and want to actually have all your Jetsons embedded into one server at the edge or in the central office. We have our array server, supports up to 24 Jetson cards. It also has an i7 COM board that you can actually manage some of the Intel virtualization and also system management on top of. And then we have a smaller box that's fanless as well that can go at the very end in a customer premise or in a factory or wherever that will also support the Jetson-based products managing that AI-based architecture. And then finally, going into next year, end of this year, going into next year, we're definitely expanding our AI and edge-based platforms for the RAN environment, along with customer premise. We've been part of the UCP program. We're part of the VoLTE program with AT&T. We're going to keep driving that. Or being part of that stuff that they're driving, and also kind of integrate some of these stacks within our program. We're also going to contribute to Craig and Mike's Open Edge platform for OCP, and also look at, and this is where we want to work with OCP a little bit more, we're supplying open architectures in some of the IoT spaces, not just from a software, what we call the data river, but also in the hardware standpoint too, because we see the operators, we see data centers deploying more and more of these N-based units and these appliances in their factory floors and elsewhere for industrial IoT. And we're just going to continue to drive and be a partnership with the OCP Foundation and expanding that into ONF, ONAP, and Acrano as well. And again, thank you everyone, and thanks for the OCP group. It's been a great road as a platinum member now, and if you're not a member of OCP, I highly recommend it. So any questions? Okay, thank you.
Hi, good afternoon. My name is Kylie. I work for a company called UFISpace. We're based in Taiwan. Myself works in San Jose, California. We are new to OCP. I'm glad to be here and meet all the people. And also thanks for AT&T hosting this particular event. So since we are new, I'd like to spend a little bit to talk about our company, our vision, and kind of how we fit into these whole things. So, and then it's interesting that we start today's agenda with a Cellsite tower. We're gonna end the agenda also with a Cellsite tower. And then also a little bit, we're gonna talk about the universal CPE. So I'm gonna focus a lot on the last mile technology. But before we end, I'm going to also show you all the roadmap, what our companies are doing. So just a little bit about our company. It was founded in 2012, headquartered in Taipei, in Taiwan. And by the way, that picture on the corner is actually the physical building of the offices. We position ourselves as what we call the IDM, stands for Integrated Design Manufacturing, as compared to ODM. And the differences is because we actually position the company with an ecosystem that we actually have a strong partnership with manufacturing partner that we set up from a compliance and also from a capacity perspective. And then we target primarily into two customer sector. One is the telco space, and that's why I'm here today. And the other one is what we call the mega scale data centers, such as some of the very large cloud-based data center. So those are the two things that we focus on. We primarily are focusing on the network side and also on the compute side. So with all the network, the UFISpace, the router, we also have different arms that focus on the server. And last but not the least, with some of the legacy stuff we are working on with the wireless and the broadband as well. We are new to OCP. We just become a new member this year, 2018. I did believe that we paid the dues, so we are officially a community members. And we just talked a little bit about our company. Now let's talk a little bit about the value. As I mentioned, we set up ourselves as an integrated design manufacturing house. So we are very focused on this concept to build not just the commodity hardware and then we can port it into open source. Instead, we also want to play as a facilitator. So we build an entire value chain. So as I design and manufacture the hardware based on merchant silicon, I also have the whole ecosystem that I have the partnership with either commercial-based NOS software provider or the open base. And then to tie the entire value chain with what we call the service integrator, or sometimes you hear the term called the PPI, the post-production integrator. So the value chain is the original concept as how we set up this thing, and as a result, what we are bringing to the table to either our service provider or our mega scale data center customer is the following. It's going to be faster time to market. And then because the fact that we disaggregated the hardware and the software components, if we are building things just like most of us in this room here, we are building our hardware based on commodity hardware. So it's logical to expect we lower the ownership of the capital expense because they're based on commodity hardware. And then also because they are based on open source. So it's also reasonable to expect we can lower the total cost of ownership from an OpEx perspective because you don't focus a lot of your expenses onto paying for maintenance as you do with an OEM company, which they couple the hardware and software together. So those are the value that we thought from the beginning as part of our ecosystem, as part of our value chain, to bring this thing at a lower price from both a CapEx and an OpEx perspective, faster time to market, and last but not the least, to continue to leverage the industry with the merchant silicon hardware to continue to bring up the value and bring down the price. All right, let's talk a little bit about our sandbox. So we play into every single one of these sandbox. The presentation today, I'm going to focus mostly on the edge. And then hopefully subsequently at some point, we'll come back and talk more onto the right. So as the last mile, we focus both on the telco and also for the SOHO. the small office and the home office. On the cell side, we have the Cellsite gateway router, and which I'm going to talk a lot about today. And then on the small office, home office, we have the universal CPE. Just a little bit for the audience, as compared to the traditional CPE, customer premises equipment, the universal basically is based more on a software-defined architecture. So you, on the go, you can actually create network type of function as part of the NF3, the network function virtualization architecture. So I'm going to talk a little bit more in a little bit, but I kind of want to set the tone how the UCPE and the traditional CPE are fundamentally different. And then as we are moving from the cell tower into the aggregation, eventually into the edge and to the core. So we do have product under active development into those spaces, but we're going to focus on the last mile for the presentation today. So with that, I'm going to jump directly into the Cellsite gateway. This particular model, the S9500, the 30XX, this one comes with a 30 port, is a 1 RU. More importantly, this is compliance with the AT&T Cellsite gateway specification. And then, because I'm the last speaker, so I hear a lot about the questions from Craig and from one of the gentlemen, Jeff, who talked about this earlier. There was a lot of questions about the temperature. So I'd like to address that a little bit. The -40 to the +65, because this is what AT&T spec called the OSP, the outside plant. And then the device is actually designed to operate in a junction box underneath the cell tower in an outdoor type of environment. So that's why it's built with that kind of extreme temperature. And this is part of the mobility, the backhaul deployment. Also because of the 5G requirement, this box actually came with quite a pretty extensive of clocking support. Primarily, we are building these devices for most of the cell site for global GPS clocking. And subsequently, there will be location GPS clocking might or might not be stable. So it's a secondary. If you look at the spec, basically we are leveraging PTP, the position timing protocol, as a secondary clock source using a grandmaster feeding through the network. And then subsequently, we also have to support quite a lot of the legacy, such as the time of the day, the bits, the 1 PPS, those type of clocking. And then last but not the least, this is based on the Broadcom DNX Chroma AS chipset with the deep buffer. And I do want to point out one thing, because I hear all these questions during the day about the temperature. The Chroma AX actually has a version called the I temperature, stands for the industry temperature. That particular version of the Chroma AX actually is designed to operate at this type of extreme temperatures. It's called the S9500-30 because this device came with 30 port. And the first set of port actually are designed to run at 1/10 gig using SFP+. The next 8 port is also designed to support 25 gig using exactly the same form factor but a different optic called the SFP 28. And that particular port will bring the traffic up to 25 gig. And then the last 2 port, which is for the uplink, and we'll be using the QSFP 28. Onto your left-hand side, those are the dual power supply. They are designed to run on active-active, and then they are -48 volt designed for the outside plant environment. The airflow for this device is from the front to the back. And if I can ask the audience, just kind of keep that in mind, because later on, I'm going to explain to you with a bigger picture how the front and the back actually tie together with a particular use case. And a lot of those are what we call the SMA, the small miniature connector in the middle. those, some of those are for the clocking that we were just talking about with some of the GPS clock, the 1 PPS, so far, and so on. All right, so we just talk about the outside of the box. We talk about the physical layout, the 1RU, the extreme temperature, the port layout, the power supply, and all that. So what I like to do is to bring you inside the box, which this is a block diagram. For the purpose of this presentation, we color code the 4 major components on the block diagram, so it will be a little bit easier for the audience to kind of follow. The one right in the middle with the blue color, that is the Broadcom Chroma AX. That is our data plane. That's where the forwarding engine is. And then onto your left upper corner where the kind of brown-orange color, that is our control plane. That runs the Intel Broadwell x86 processor. That's where the network operating system will be put on top of it. And then on the left lower side, we also have the BMC. Those are all the housekeeping. This is based on the ASPEED processor that control all the BMC type of function. And then last but not the least, onto your right-hand side, onto the green, that is actually, we introduced this thing called the external digital phase lock loop. It's by ITT, Integrated Device Technology. The reason we actually bring in a external digital phase lock loop is for the reason we just talked about because of the clocking. This box, in order to meet the AT&T compliance, we had to support about 6 different types of clock source for the 5G and also for the legacy. And with the amount of different type of clock source that we need to support in a scalable way, so this external phase lock loop device from ITT was introduced to integrate with the Chroma AX. All right, so this is the inside of the box by the 4 different functions that I just talked about. All right, we are new to OCP. We are learning a lot about OCP. We believe in sharing of information. I learned a lot from everybody today, and I expect that we're going to be doing a lot of great work together. So with that, we do have a plan and a commitment to contribute to the OCP with these particular devices. This device right now is more or less into its final phase of going through the NAPS Level 3 testing. And we expect this will be completed by Q1 of next year. So with that, we expect general availability will be March of 2019. And that is also the same time that we plan to do the contribution. And coincidentally, that is also the next OCP Summit in San Jose, California. So we just, all the schedule lines up pretty well. The sample is already available now. We are actually doing quite a bit of beta test kind of stuff, you know, in the field. All right, so going back to the temperature, OCP is all about sharing information with the audience. So rather than me coming here to tell you how good my box is, I also like to tell you how this box is actually, or in general, what a cell site gateway is being deployed. So with the courtesy of AT&T, under permission, we were invited to take some pictures from a tower. This picture we're taking in New Jersey in preparation for this presentation. So what you are looking at is a typical cell tower on the left. And if you look at the antenna, behind the antenna is what they have the radio control unit, or the RU. And it actually runs a signal or a protocol called the Common Public Radio Interface, CLPI, downlink to another unit called the BBU, or the broadband base unit. And that broadband base unit actually sits in this particular box. That will shift the high frequency signal to a baseband and then that will fit into a internet interface of the cell site gateway. So the BBU and also the cell site gateway router actually sits in one of these boxes. This is the back of the box. I think what Craig earlier talked about, that's a way how the air flow was moving. If you look at the picture in the middle on the top half where the ventilation, that's exactly what that is. AT&T call these the heat exchanger. So it's actually a mechanism that they actually can circulate the air onto that section of the junction box to release the heat. So if you remember, one of the things I talked about earlier that I call it out is the airflow is from the front to the back. That's exactly the reason, because the heat exchanger is actually on the back of the outside junction box. And then they will be able to circulate the air with this heat exchanger mechanism to get the cool air out. And that's how this thing is designed to run at plus 65 down to a minus 40. This is kind of the back of the devices. If you look at my left here, this is kind of like a 45-degree angle. At the time when the picture was taken, I was trying to like go around and take a picture with the front so you can actually see if the door were open, how the cell site gateway router will be installed. But this thing is actually protected with fans, and I was not able to get through it. And to make it even more challenge, this cell site we were invited to was actually coexist with a police station. So I was kind of need to be in my best behavior when I took these pictures. But yeah, the 45-degree angle was kind of the best I can show you. But I think more importantly is I hear a couple questions during the audience today, the extreme temperature, the plus 65 degree and all that. So I thought I would want to show the heat exchanger mechanism on the back, how this cell router actually goes in, same as the BBU. This whole thing operates at minus 48 volt DC as any telco OSP outside plant type of equipment. And as I mentioned, we are doing the NAPS 3, the NAPS level 3 compliance on top with the TP76 200 supplement. So those are the things that we are working on. We expect everything will be all completed by March of 2019. All right. Okay, so I'd like to shift a little bit to talk about the UCPE. We just talked about pretty extensive on the cell site gateway. Those are on the cellular network. Now we are moving still on the last mile, but this is more for the SOHO, for the small office and the home office. What I brought to the audience today is two types of universal CPE. This particular one is a desktop. In a second, I'm going to show you the rack mount. Both versions actually all leverage the Intel technology. More importantly, we also leverage the Intel QAT, the quick access, for the hardware crypto accelerations, all right? And as I mentioned during the beginning of the talk, the letter U, the universal, basically imply we can define virtual type of network function. In this case, we are leveraging is the single root I/O virtualization over the PCI Express. So we were able to create the virtual function using the SR-IOV. These particular devices also support in some of the downlink port with the PoE Plus to address things such as typical like IP phone, wireless access point. The fact that with the PoE Plus, the AO2.3AT, because we also might consider things that has an electric motor that might plug into it, such as surveillance cameras. Some of the surveillance camera, actually you can move the head and that's an electric motor that might drive a little bit higher current. So those are the things that we've been consider. Last but not the least, we have the PCIe for the Wi-Fi and also the M2 socket for the LTE option if one chooses to. And similarly, this is also a UCPE, also leveraging the Intel architecture, also using the OAT, the QAT as the crypto acceleration. This is a red mount, so basically has a higher port density, still leveraging the SRIO virtualizations for the benefit that we just talked about. Okay, trying to bring everything together. So far, we talk about our sandbox that we go from the last mile and then to the edge aggregation and then into the core. So for the last half an hour, we focused quite a lot on the cell site gateway for the telco side. We focus also a little bit on the universal CPE for the SOHO offices. So to bring everything home, I'd like to share with the audience, these are the two other categories of product that we are actively working on. One of them is as we go through the aggregation into the core, we are building a 400 gig solution as we speak. It's based on the QSFP double density technology. This is a disaggregated architecture, meaning that it has a fabric and it also has the line card, all right? So for those of us who've been in the networking industry for a while, if every time you see kind of like disaggregated architecture with the fabric and the line card, we're pretty much doing this for one main reason, and that is to for scalability, to make things more scalable. So that's the approach that we take. Depends on how the open source NOS will be ported. I would speculate the controller probably will be running something like a RESTful API or something similar downlink for the configuration, and then RESTful API uplink for things like analytic or orchestration, that type of purposes. But we are focusing on the 400 gig, and then we probably will be partnering with others on the controllers and some of these other controlling protocols that we just talked about. And on the bottom is the aggregation. We are also looking at a solution with a deep buffer. As all the cell site gateway, they are being aggregated from all the different locations, and then they will be home into a aggregation device before they fit it into either a metro Ethernet or some type of transport before they get back to the central office. So as you can see, we are doing quite a lot on the edge, on the last mile today, both for the cellular and also for the small office, home office. We are building solutions for both the aggregation and then also into the core. I listened to some of the comments today, and this actually kind of apply. The comment was about the 400 gig, and this actually applied to some of the things that we are seeing as well. So I kind of want to share with the audience. Building a 400 gig switch, we know how to do it. There are chipsets out there like a Jericho 2, with a deep buffer like a OP2. Those type of chipsets, they are available. The thing that we are actively working on is actually partnering with the optics vendor, because the 400 gig optic are still kind of, being developed as we speak right now. And in some of the homework we have done, I guess a lot of the optics provider probably will have their 400 gig optic available about second half of 2019. So as you're trying to build a switch and you're trying to kind of get a sample to make your optics and your switch development testing. So those are the things that we are facing. And I can also share with you some of the things we're looking at. The 400 gig optic are the fiber rich, the FR, the DR, the data center rich, and also the BD bidirection 4.2. So just to give you an idea, those are some of the 400 gig optics that we are trying to partner with the some of the optic vendor that can be available at this point. So all in all, we are playing in all different sandboxes, and we spent today the last 23 minutes to talk about our last mile, namely on the Cellsite gateway and also on the SOHO UCPE. And then these are the roadmap, and then we intend to share more as the information become more mature. And last but not the least, we look forward doing more with OCP and then do our first contribution in March of 2019 in San Jose. So with that, I'd like to open for questions or anything I can answer. Anything? Thank you.
Hey, I have one.
Yes, that's a question. Yes. Somebody had a question?
No, I have a comment.
Oh, yes, sir.
On the wiki, we have a section that's neither specification or draft specifications, accepted or draft specifications, but one that's called a section for information that may be useful to developers. And so in that, I was just looking at that, and I noticed that we have included TP 26207, which is the integrated cloud computing physical specs, and also 26208, the OLT. So I noticed that you had a couple of others. If you would send me those, I'd be more than happy to put a link on there.
Great.
So that we can all have kind of a common understanding as we go forward of where these requirements are coming from. I think that helped us out a lot when we were in the early days when we were talking about the computes and how this was different from data centers, and then how the OLT devices had a little more stringent requirements than the compute requirements, which AT&T had just worked on relaxing a lot of the data center equipment requirements, right?
Okay, great. I'll do that. Yeah, thank you.
Yeah.
Yeah, thanks for pointing that out.
And just to let everyone else know that the kind of things that you'll find on the wiki as well.
Yep, that sounds good. Thank you.
Yes.
Appreciate you bring that up. All right, thanks again.
So I guess that ends our afternoon session for presentations, and I guess we have a little over an hour for any open topics that anyone would like to bring up, or if you have additional feedback, questions, we can go from there. Do you want to come up here, or?
No, that's okay. So two topics I wanted to discuss is you presented the OLT platform, and I wanted to open up the discussion if people are interested in maybe enhancing the scope and doing what we call the generic, say, application, a wide variety of application access platform, so multi-application platform using the same FPGAs that we have on the OLT. Instead of just supporting OLT application, we can have a variety of access applications supported in this chassis. So for example, it could support ECPRE for one technology, or virtual BRAS, or just Ethernet access, and be a multiple access platform. So I was interested to hear some feedback if people are interested in that. Okay.
I absolutely like that idea and do support that. I think would like to see more in the either on the telco calls that we do monthly, or during other events. It would be good to get some contributions, so that way I think folks can understand better, right, what we're trying to say, and maybe we can get feedback that way also.
Sure.
Because I think you'll get a broader option of people that beyond this room, and I think that you might be able to start a conversation that way too.
Okay,
Get some
we'll do
immediate
that.
feedback.
I want to get some initial feedback, but that's also okay.
Right. I mean, I think we don't have that many operators today. I
Exactly.
think, so, other than AT&T. It would be good. Like Archna said, we'll bring it up on the email
Great.
or the calls.
And we would love for our mail list, as you saw, there's quite a number of people that at least monitor the mail list. And it sometimes feels like the mail list is our own personal broadcast channel to say, hey, there's a meeting coming up, or the call's coming up, here's the agenda for the call. Does anybody have an agenda item? But it would really be nice to have conversations going on the mail list. That's really its intended purpose, not a broadcast medium for the co-chairs to use to give announcements of upcoming things, but to have discussions. Yeah. But I think it would really be, I agree with Sumithra, it would be a great thing to have a presentation, some slides and stuff so that we could do it on the call to kind of, get a little more vetting of the idea, what you're talking about, how it would work. And in particular, I'm kind of, I find myself drawn to like P4 lately. And so, the not really understanding what that means, but from a, 10,000 foot view, it looks like I can do switch things and I can do FPGA things with some similar code. So that might be I know we don't have, that effort is not captured in an OCP project currently. It's being done in the Open Network Forum, but it's something that if we could get applications that have more applicability to the Open Compute Foundation, we could start that. The software and firmware is a new topic that we've started taking more work on, and so we've now working on our framework of the code repository and those kind of things. So it would be might be a good jumping off point for us to get some lower level, not a full stack kind of a thing like we were talking about earlier today, but that might be a good place for that as well. Just kind of throwing things out, how that yeah.
Yeah, so the other thing I was going to say is if it is a topic that might transcend both the telco group as well as the networking group, you might want to throw it out to the networking mailing list too. I know that we've had lots of conversations, as Craig was saying, on hardware management where they're defining redfish profiles for switches, for routers, things like that. I know they're already doing it for server and they're doing it for racks, but I know they're migrating it to other segments too. So I think that you're going to get much more broader if you throw something out there, and if it need be, I know we're open to like forming a subgroup that might be a hybrid of both the networking group and the telco group. It's happened before. That's how OpenEdge was kind of formed, where Nokia came to us and said, hey, this is a great idea, and we looked at it and we're like, yeah, we're not covering it, let's do it, right? And if it needs to be across ONS or the Open Networking Foundation, we can do that too. I mean, we did that at the Amsterdam Summit where we put a VCO demo together and kind of brought everybody together, right? Our software group as well as our networking and the telco group. So I think it's really relevant, especially when you have themes that are gonna bleed across multiple groups.
So the initial discussion was focused on the telco group. The networking group, and before it's separate, we'll discuss it offline and then decide. Let's start with one. So.
Yeah, absolutely. I think, yeah. All right, we've got a few more workshops coming up. They'll be on our events calendar, but the big one is next year in March 14th and 15th in San Jose. It's our global summit. So I know registration is going to start soon, but more importantly for the crowd here, call for papers and abstracts if you want to present at the summit is going to be going out November 1st. So keep an eye on your email for that coming out, and if you're interested in participating in presenting, please submit your abstract as quickly as possible. I think we had over 200 abstracts submitted last year, and we whittled it down to 50 because that's pretty much all we had the time for. So I know that we're going to start to look at those. So with that, thank you again to AT&T.
So
Go
Wait a
ahead.
minute, we got time.
Oh, yeah.
We have time here, I'm sorry, I got you guys for a while.
Captive audience.
There's a couple topics that we had from the project that we'd like some feedback on, especially, I hate to give up this high bandwidth session that we have to ask some things. So the first one, and this is something that the incubation committee chairperson actually started a few months ago about where does OCP go from here? How do we progress? And one of the things that I'd like to find out from the group is there anything that we need to be doing to help the community? And is there anything that the community thinks that they might like to be working on that's currently not worked on? Obviously, we have our projects that are ongoing that are specification driven. We're looking for the white paper, the reference architectures, those kinds of submissions as well. But just from the, is there any areas that you feel like we may be missing that we need more coverage on? Anything like that for the group, where the group's going? Do we need to make any charter changes to accommodate that? No. They're doing everything great. Nothing. Telco group's in great shape. That's what we told him. We were like, oh, we're the only group that's spot on. We don't need to change anything or work on anything new. But I guess with that, if you could think about it then. If there's something that comes to mind, either send it to the mail list if you feel comfortable, or send it directly to one of us, including obviously Jeff on that as well, because it's an IC kind of sponsored thing of setting the direction for the OCP as a whole, where the project is going, foundation is moving, not just the project.
So Craig, one quick question for you on the telecom group. As we start seeing more influx of ONAP and ONF and Acrano and ETSI-MEC and all these different software infrastructures, as we're building our products for hardware, should we start looking at how does these fit inside? What are some common, like OpenBMC and Redfish, you need a BMC controller that has to fit all that data within that BMC controller. So as we start submitting specifications either for approval or just for inspiration, should we maybe start setting some guidelines on this is what the template should include within that environment? Do we include common elements to manage the product, to cool the product and all this within the OCP? I don't want to put boundaries around us, that's not my intent, but maybe doing some common elements that are common across most infrastructures.
Right, well, I'll tell you, let me give you two examples for I guess food for thought or more discussion perhaps. One is Redfish. So the foundation has, we've decided as a community that we're going to go forward with Redfish. And as some of you have, submitted your checklist, I've made questions about your Redfish, and it's the Redfish profile is not the full Redfish profile, but rather it's kind of trimmed back for each of the projects. So every project has a slimmer set of Redfish elements that are kind of expected to be present, and we would like to make that become more as time goes on, and as the Redfish, the DMTF makes more profiles. Obviously, the server group has a higher number of requirements for Redfish elements than we do. But from a hardware management standpoint,
that seems to be the framework that's in place so that, if nothing else, at the end of the day, we'd like to be able to say, it has power, it doesn't have power, it's having a fault, it's not having a fault, those kind of things from Redfish. And we can, go back and look at our Redfish requirement, which was right before the summit last year. And, we might like to add or change that as a group. That's probably one of the things we'd like to do. The second item is the work with the open source groups has somewhat been led by, say, AT&T, and really, by AT&T, because the common thread is AT&T had an architecture, they developed some things in-house, then they have worked with other communities on software, and what we're now seeing is the fulfillment of that vision that AT&T had for open GPON. And so now with the software elements that are in there, and I think that that's very important that we end up with not only open hardware, but also open software, because if you don't have, if they don't work together and you can't then show a reference architecture or a white paper on a use case of how that open hardware works in the real world, which means, having some manageability, having, firmware necessary to operate the box, and then having some application software. Without all of that, it doesn't work. And that's why I was also saying that it's nice that in the past, couple of years, the foundation has worked very hard on both hiring some resources within the foundation to guide this effort, and then two, to set up the infrastructure from a code repository standpoint for us to be able to do this kind of work. Now, a lot of us are more hardware oriented than software oriented, but I know that in Nokia, for instance, I have this conversation, usually at least a couple of times a month, if not, more frequent, on, hey guys, we're a solution provider. We make a solution that uses OCP hardware, and we have a software stack that's associated with that, and we have a management stack that's associated with that, and we should be, sharing that in the form of reference architectures and white papers to show how all of these elements can go together in order to provide a solution. And so, while I'm not a software expert, the company has it, and so most of our companies are probably in that same shape, and it may take getting some additional people involved. And I'd have to actually look at the charter, but I would doubt that we would have to do anything to the charter, because it was meant to be kind of overly broad at the beginning to allow us the leeway to do those kinds of activities, when we started the group. So, does that answer your question? Or? Go ahead.
Like you said, AT&T has been driving some of the open source, and it's important to connect, right? What's happening in other communities and how the OCP hardware is becoming relevant with other open source software. That was why we also had ONF present today. So we kind of get an overview. We had I think Timon was there in Austin. And we saw a lot of interest in the group trying to learn more about how are we going to be implementing, right? More of a reference architecture or a design. That's kind of the intent, bringing, collaborating with others. I think in the future it would meaning I think we should probably do more of this, right? And even get to like demos and be working together. Yeah, right. Joint workshops, right? Maybe something to target for the summit. I think that would be a good place.
Absolutely.
Right.
No, that's a great idea.
And Archna also just brought up another good point on the optics. I think there are a lot of innovations and things happening around optics, and it's very relevant to the telco group as well, right? I think it would be good to see more contributions and roadmap of where we are heading. I think that would be another future topic for us to explore and get more involved into.
So Jeff, was that what you were thinking, or did you have any some additional thoughts on that, or how that would?
Well, as a manufacturer, and I think my friend up here that presented last as well, because we do support so many service providers and customers, a lot of times it's very, very difficult for us to understand the different elements, because we, within OCP, AT&T is driving it, but when we go meet with someone like a Telefonica or someone else, their frame sizes may be different. So what we're trying to do is build products that can match the industry, but have nuances that meet their specific needs. So when we talk software, having a good understanding of what AT&T is doing and Telefonica and all that, and when we develop specs, when we actually put in specs that we expect to be approved, then is there a subset of this needs to support ONF version 3.0, or this needs to support software level XYZ, just as a foundation. So when we do submit it, then we can go back to those different customers and say, the rest of the world is saying this is what we're wanting. If you don't, then we'll make changes, but this is kind of a foundation that we can build on. That kind of makes sense. It's complex, but I need a starting point.
Yeah, and I really thought that what was interesting today was how they have changed from loading an operating system to acknowledging the fact that the different carriers want different operating systems that they have vetted themselves and different versions, and saying, hey, okay, you know what, we're going to go a level higher. We're going to go with Kubernetes and containers, and you can load whatever operating system you'd like. Now, I'm sure there's some caveats there probably that support some version of Kubernetes and some flavor of Docker, right? So it's not total carte blanche, but there's some ability there to give you some flexibility. And that's kind of essentially somewhat of what you're saying. Because
I don't want to
get those same
put boundaries around
that are.
Yeah, I don't want to put huge boundaries saying you got to use Kubernetes 2.x.
Right.
This is all commoditized, chipsets and hardware. So we want to be flexible enough. But there are some low-level things that when we build a product that we have to future-proof it. And maybe that's as a team from the telecom group, we can put our heads together and say this is a minimum set of requirements that can go in, and then get the approval from the operators. And really, it's the operators that have skin in the game, right? They're the ones that, like NEBs, like do we actually need NEBs at a radio tower, and do we use the same NEB specifications? Just those type of things as we build the product, have that in tune. Does that make sense?
Yeah. Yeah, maybe we could do that. Sumithra, is have a session from the foundation kind of back to the group on the firmware, software efforts and how that might fit in, as well. I was trying to put a concrete action item for these things so we can, figure out how to get more information out.
Yeah, meaning now that we, kind of heard some feedback. Yeah, like you said, we'll put together something and then even do a call for contribution on certain topics, so that way we're all more focused on what we want, right?
Yes.
I think that's a good idea.
Touch base with TIP and also like ONF and ONS and see if there's alignment there, because I think that's what.
Where's your microphone?
Huh?
There's microphones everywhere.
I'm
Grab
sorry.
one.
I'm like, you might want to get a hold of, or I can facilitate it with TIP as well, because TIP just had their summit in, in London. So they may have some ideas too where we can collaborate, because they have a lot of carriers like Telefonica, like DT, like BT, Verizon. So it might be interesting to get that cross collaboration going. Just a thought.
Yeah. I think it would be, we had a TIP representative presented to us. I think it was at a workshop.
I think it was, I remember one last year.
Well, no, this was at least 2 years ago.
We had one last year too, right? I think in November, we had a telco session during a TIP summit. So that way we did have some, some of the TIP folks come join in, and I know we talked about
did they give good information though? The one I remember was just kind of generic. We don't really know yet. We're still kind of organizing.
There's a lot that's happened in 2 years at TIP, right? So I think that it'd be good to get an update, right?
Right, that's what I'm saying. Yeah. They may have a little more, it's not just kind of nebulous in the air like that one was. Or at least that was my impression of it.
So I think, we kind of had a very good session, some good feedback. Anything last minute before we end the session? Okay. All right. Thank you, everyone. Thanks to all the presenters. Very, very good information. And I hope to see you all next time.